And okay, today I will teach you about the first one is binomial model. Last time that we finished logic equation, right? The outcome of interest is fine. And for today, that you work on the outline for this topic. First, I will give you the basic knowledge of binomial model. And then teach you how to construct the multi-model model. And then after we see the model, I will teach you how to estimate the parameter model and estimate correlation. And at the end, we will work on data analysis. I will go to the first topic about basic concept of for the basic of polynomial model. First, you need to know about when we analyze the data, you need to answer one question, like from the type of outcome. The type of outcome is the keyword or selected appropriate. For multinomial model, type of outcome can be like a overall categorical model, but has more than two groups that define nominal variable, and then we like has more than two categories, and without order among categories. In case that the categorical variable and has order, for example, my moderate sigma, we can use another model that we call ordinal multiplication. For categorical data that have order, we will apply ordinal multiplication. But in this case, the categorical variable but not like order. And I will give you an example. And the aim of applying multinomial model is the same as multiplication model. We would like to like predict the outcome of predictor is the same as multiplication. But the type of outcome are different. This is an example of applying multinomial multiplication. The study design is cohort study. Cohort study of a patient with advanced SCC. The reservation is what predictors associated with receiving treatment for advanced SCC. It means that we would like to define the factor associated with treatment assignment. Because this is for observational study, right? For RCT, you can like allocate the patient to each treatment group, but in observational study, we cannot allocate like a randomization for the treatment. The patient will receive the treatment according to their condition and like a payment scheme. So that's why we need to identify the factor that associated with receiving and the treatment for advanced SCC that are three regimen. First regimen we call sorafenib, and the second is 5-FOXO, and the third one is doxorubicin. And the researcher tried to review what predictor that associated with treatment allocation, such as your progress, speed, age, underlying disease, and immune function. Okay, right now you know that when you apply multinomial, when you have like the game of study to identify the factor that associated with the outcome and type of outcome has solvable variable without order and has more than two categories. Next, I will show you about step of multinomial logistic model. We call multinomial logistic model or multinomial model. First, before we analyze, we need to select one of the category as the baseline category. And then the second step is fit logistification for K minus categories. It means like this is the extension of logistification model. When we talk logistification model, you have only two groups of the outcome, right? And one is the reference group on disease, and disease is the interested group, right? And for multinomial model, you have more than two groups. So it's the same concept, like you need to specify the reference group of the outcome. And after that, we will fit logistic equation for k minus 1. It means that if we have three categories, we need to fit the logistic equation for two. The one compared between like another group with the reference group, and into that. So if during like when we apply logistic equation, when you fit the model, you just only determine the reference group for the factor, right? And for the multinomial equation, you need to specify the reference group for the outcome and reference group for the predictor. Okay. This is an example. This example is like we would like to identify the factor that associated with receiving treatment choice. The factor of interest is health speed. It is divided into like civil medical benefits. It's like a CS, MPS, and we classify another group as like a non-government. In Thailand, we divided the health scheme to make it's like a payment according to government officer. And another group is like a payment by yourself or payment by others scheme. So we divided only two groups. CS, MPS, and non-CS, MPS. The left-hand group is non-CS, MPS. And for the outcome, right now the outcome is treatment of disease. And the researcher think that the solar limit is the left-hand group because in setting in Thailand, most of the people like have the social policy. Most of them can receive, also receive or so forth. And for solar limit, the specific for some patients because the treatment is very expensive. And that's only the patient who work in office government can receive the solar limit. It's like a carry payment. But for other payment, we need to pay by ourselves. So the researcher make decision that solar limit to be as the group of the treatment. Okay, and then we can fit the multinomial model by fit the logistic equation for two logistic equations. The first one we compare between doxorubicin compared with solar limit. And then we get one equation and the factor with coefficient and B01 is for intersect of this equation. And for the second logic model, compare between Firefox compared with solar limit. After we understand how to fit the model, we can apply the second concept to estimate the parameter in the model. The parameter of interest in the model, there are two types. The first we call coefficient of association between predictor and outcome. And the second one we call we will estimate the probability of being in treatment of each outcome. There are two parameters that we estimate the result. Okay, we go to the first parameter that we call coefficient of association with predictor. This is an example of the data set that we will work on. This research objective is try to define the association with the treatment and effect to the outcome. Researchers would like to determine treatment outcome of advanced hepatocellular carcinoma in development, chemotherapy or sarcoptic therapy. For this study, the aim is they would like to look at the outcome after receiving the treatment. But however, the study design observational study. So the first step, we need to identify the factor that associated with receiving treatment first. And after that, we will estimate the probability of receiving treatment and apply propensity score that we will learn in the treatment effect module topic at the end of this. We have one topic about treatment effect, but this is like the part of that analysis. So we have like a two part. The first part, we identify the predictor that associated with receiving treatment, and after that, we will apply this model to balance the characteristic of patient and then move to the outcome. But for this step, I would like to explain to understand the multi-level. Okay, I'm going to open the data file, and the file name is N1 SCC code. After you open the file, this is respective information. The variable first L is like a first element that consists of sorafenib, doxorubicin, and the factor is about cholecystine. The variable name is SCS group. This is like the descriptive information. Before we start to analyze the data, every time we need to look at the descriptive information. At this time, I would like to focus only two factors, outcome and predictor. The outcome of interest is the that have three categories, and the outcome has two groups divided into like a payment by officer, voting officer, and non-voting officer. It also just give one part. And tabulate is to one vote. The number of subjects is 672. And after that, you can fit the logic equation by use the command nlogic. You type nlogic and then follow by the outcome variable, which is right now the outcome variable is treatment, right? And then follow up with the predictor, which is like the probability. This is categorical variable. So we need to put either in front of the variable. And for this command will select the smallest number as the lesser group. For the outcome of treatment, first is sorafenib. Therefore, sorafenib is the lesser group. But however, we can change the lesser group by ourselves, and I will explain. Right now, I have to go to resolve. Don't forget to open the log file for how to support here. That we can review later. All two can fit because no need, right? And you got the result on this screen. Okay, next I will explain the output, how to interpret the result. The result of multinomial logic equation divided into this outcome panel. So it divided into 3 panels. The first panel, like for the first group, and the second panel and third panel for each category of that variable. We call outcome panel. And for the first panel is baseline of outcome because they say base outcome, right? The first panel is baseline of outcome, and then as you can see, the way that they specify the reference group automatically by the default, they look at the mode observation in the sample was set as the baseline outcome. For multi-logic, they will select by default of the logic command. They will select the largest observation as the reference group of the outcome. And the second panel, they talk about the effect of dorsal receive compared with solar. And as you can see, this is the coefficient that compare between payment by government officer and non-government officer. Code 1 for payment government officer and 0 for non-government officer. And the way to interpret the result, as you can see, there is negative value, right? It means that the patient correlated by government officer will less likely, because minus value is less likely to receive dorsal receive rather than solar field. Okay, compare with patient without government officer. When we integrate the result, we have to integrate like the 2 steps. The first step, we compare between the outcome, right? Dorsal and solar field. And we say that for minus, for negative value, the patient has less likely to receive dorsal receive compared to solar field. Okay, rather than and compare with non-officer, government officer. Okay, and the third panel compare between the effect of treatment compare between Firefox and solar field. The result the coefficient is negative value. It means that the patient that would have government officer payment by government officer will less likely to receive Firefox compared to solar field, and compare with those who did not government officer. Okay. This is the way to interpret the result. Does anybody have question about interpret the result? Less likely ใช่ค่ะใช่ค่ะ yes from multinomial prepare between different group of outcome
and different group of factor yes ค่ะokay and the next step I would like you to change the reference group to doxorubicin as you see the command you fit the same command mlogic with the treatment variable and then I dot SCS group is about health correlate and then comma you need to specify option base and then the number of reference group in the parenthesis right now I change the reference group for sorafenib to doxorubicin okay you can fit in your data for IV dot is like you specify the reference group for predictor and for option base you specify the reference group for the outcome right now we have to specify two reference group for the outcome and for the predictor for predictor is the same you can if you like to set like the reference group is like a payment based on by government officer you can IV one okay and I will try to show right now in this case more complicated than logistic because we need to set two reference group both predictor and outcome okay the way to set the reference group for the predictor is the same as last time IB and then the reference group in the parenthesis right and for this model you need to specify the reference for outcome okay and we will practice together I like to explain the concept first okay have you got this output on your screen okay and the first model is sorafenib compared with doxorubicin. And as you can see right now, the coefficient is positive value, right? It means that the patient who like a correlate by government office, like a government office, like a more likely, right? Because it's positive, more likely to receive sorafenib than doxorubicin and compare with the patient who did not government officer. Okay. The positive effect. And the second logic model compare between Firefox with doxorubicin. The same is the positive effect. It means that the patient who like a government officer will more likely to receive Firefox rather than doxorubicin compared with non-government officer.
In the SATA as we said is
because in data we have many like a classify many group and in this case we combine payment by government plus pay by self-pay and another group is like a SSS นะคะ social อะไรคะ ใช่ค่ะ and ใช่อยู่4 covalent okay try to work on another variable okay I have another variable sex can tabulate sex male and female right I would like you to specify the reference group of the outcome is doxorubicin, and the reference group for the gender is female. Right. First, you need to specify the reference group for predictor, which is female. Code is number 2. And the reference group for the outcome, which is doxorubicin. And then you enter. This is positive value, right? It means that male has like a more likely to receive sorafenib rather than doxo compared to female. Okay. And for the Firefox, this is like a male have opportunity, right? Like a more likely to receive Firefox rather than doxorubicin compared to female. Try another variable. Alcohol cirrhosis. Okay. Alcohol cirrhosis. Which is code 0 and 1, right? For predictor. Which one should be reference group for the predictor? Should be 0, right? For non-disease or non-alcoholic cirrhosis should be reference group of predictor, right? I would like you to fit M logic with the variable, right? And then I dot alcohol cirrhosis. And then base doxorubicin is like chemotherapy ใช่ไหมคะ Okay. And then you look at the result. The patient who have cirrhosis has like less likely, right? Less likely to receive sorafenib compared to doxorubicin. Compare with the patient who did not have cirrhosis. And the same for Firefox. The patient who has cirrhosis was like less likely to receive Firefox compared to non-cirrhosis. After this one, after this effect, the next step, we would like to estimate the probability of receiving each outcome. For example, I would like to explain a little bit. For example, for this result about cirrhosis and non-cirrhosis, compare with sorafenib and doxorubicin. What do you think about the probability of receive sorafenib or doxorubicin for the patient who had cirrhosis? Like high probability or low probability to receive sorafenib. What do you think? If the patient have cirrhosis, what should be like what they should be received according to this result? Doxorubicin, right? It's like the probability of receiving doxorubicin for cirrhosis, it should be higher compared to sorafenib. Okay, that is the next step that we need to estimate the probability of having each outcome. I will show you. This is the equation, the first model, based on the first model, logic model, and at the end you get the probability of receiving outcome A. And based on second logic model, you can get the probability of receiving receiving treatment B. And based on this equation, it means that probability of receiving all treatment for each treatment, when we combine them all together, the probability is equal 1. Right? For A, B, C, probability receive A, B, and C equal 1. This is like an overall probability. So it means that if we would like to determine probability of C, we know that the probability for B and for A and B that we can get probability of receiving treatment C. Based on this equation, you can perform based on data program. First, we fit the model. Okay, I think it's better. Right now, we are on the variable cirrhosis. Okay, and the reference group is doxorubicin. After you fit the model, the next step you need to estimate the probability of have or receiving each treatment by using the command predict. And then I set the new variable prop of treatment of treat, and then star. Because at the end, you will get the probability of receiving each treatment, right? More than 2. So we can use like the same variable but different number at the end. Okay, that's why we plot treat star. Okay, and then comma, and then PR. And then enter. And then you will get the new variable at the end, right? Probability of receiving sorafenib, doxorubicin, and Firefox. You can how to show the result. You can use this command to show the result. You use the command margins. Show the result on the screen. Margins, comma, coefficient. It means like a show on the screen and then post. After you use predict command, you will get 3 variables, right? But we would like to look at the probability of receiving each treatment on the screen. So you can use the command margins, comma, coefficient. Coefficient is mean this one, the coefficient, like the variable that keep the value of coefficient in the data program. And then post, have you got this one? But different result because this is from health correlate. What is your result for cirrhosis? Say margin, right? Margin, coefficient, post. Okay, you can get based on this equation. The probability of receiving the code 1 is sorafenib is about 0.5, and the probability of this is like overall for doxorubicin about 25%, and the probability of receiving Firefox is about 18%. This is like overall. And next, we would like to look, this is the same, this is for overall, but if you would like to look at probability of receiving treatment for each exposure, for each factor, So we need to estimate and then specify for exposure นะคะ and then probability of being each outcome for non-exposure. Okay, this is the equation. And then you can use the command margins by factor that you fit in the model ค่ะ you use the command the same นะคะ margin for export but you add okay by and then in parentheses the variable that you fit in the equation which is alcohol cirrhosis, right? The last equation. This is the factor that you put in the model. Okay, and then enter ค่ะ Have you got error? This is like because when we would like to use the command margin นะคะ after you fit the model, even though fit the model and use margin and then you start a new one นะคะ so you can go back to the command mlogic, fit the mlogic for cirrhosis first, and then you can use the command margin. Okay, you will get the result. The command margin is after fit the mlogic นะคะ if you fit mlogic and use other command and we try to use margin again, it will forget like what the final model that you need to estimate the probability. So you need to go to fit the mlogic again นะคะ and then look at and then use the command margin to predict the probability of having receiving treatment for each exposure for each group of cirrhosis and non-cirrhosis. Okay, and as you can see, the number one is treatment number one, which is sorafenib, right? And then for zero is no, it means non-cirrhosis. The probability of receiving sorafenib in the patient without cirrhosis is about 59 or 60%. And then you can compare with the second one. Is the patient, the probability of receiving sorafenib compared to the patient who receive, compare the patient with cirrhosis. If the patient have cirrhosis, probability of receive sorafenib is lower compared to the patient without cirrhosis, right? And when you look at number two is for doxorubicin, right? For doxorubicin, the patient who has like a cirrhosis, higher probability to receive doxo is about 42% compared to the patient without cirrhosis, only 20%. And when you compare with Firefox, the patient who did not have cirrhosis has like a higher probability compared to the patient with cirrhosis. And when we prepare present the result, I will present the result as this. As you can, this is another variable, this is about payment. And as you can see that for the payment, the patient have high probability to receive sorafenib is 90%. And other treatment is a small. Okay, if we would like to compare this with this one, you can say for the patient who have cirrhosis, which one is the high probability for the patient who receives cirrhosis, who has cirrhosis? For the patient who have cirrhosis, probability to receive sorafenib is about 59% or 60%, right? And then the patient who have cirrhosis receive doxo about 42%, right? And then for receive what is called Firefox is about 15%. It means that if the patient has cirrhosis, the probability of receive sorafenib is higher. It's more likely to receive sorafenib for the patient with cirrhosis. Okay, sorry. 53% for sorafenib. Okay, thank you. 43%. Okay, and for doxo is about 42, right? And then for sorafenib, for Firefox is about 15%. Okay, it means that the patient who have cirrhosis is 43% receive sorafenib and 42% receive doxo. When you look at the equation, and as you can see, the patient who have cirrhosis is less likely to receive sorafenib compared to less likely to receive sorafenib rather than doxo, right? Compared to non-cirrhosis. Okay, and this one for the probability for export who receive sorafenib, and then you compare with the patient who did not have cirrhosis. The probability to receive sorafenib is 60%. And then for doxo, about 22%. And for this one is 89%.
This is only one.
This is just only one factor. And as you can see, if we compare with cirrhosis and non-cirrhosis, cirrhosis the patient who has cirrhosis has lower probability to receive sorafenib compared to the patient who did not have cirrhosis. Okay, 43 with 60. And for doxorubicin, the patient who has cirrhosis, the probability of receiving sorafenib 42 compared to 22 for non-cirrhosis. It means that the patient with cirrhosis has higher probability to receive doxo, right, compared to non-cirrhosis. Okay, this is the way to interpret the result, because we would like to look at which one, which factor that can predict the probability of receive each treatment. This is just only univariate analysis, and I will show you at the end how to define the factor that associated with receiving treatment. Okay, and after that, after we get the probability of receiving treatment, the next step we will estimate the odds ratio. The way to estimate the odds ratio, you just only specify the option RRR at the end. We can based on cirrhosis. You use the command mlogit as the same, and then add the option RRR to get the odds ratio. RRR to get the odds ratio. Oh, 3. RRR. And then enter. Okay. The value that you get is odds ratio, that you can say that the patient who has cirrhosis has lower chance to receive sorafenib. About how many percent? 63% lower, right, to receive sorafenib rather than doxorubicin compared with non-cirrhosis. And for odds ratio for Firefox, because it's less than 1. Less than 1 is mean that lower chance to receive Firefox compared to doxo, and then compared to non-cirrhosis. Okay, it's the odds ratio that show the strength of association. How large is large, how small is small. This one is the way to interpret the result as I explained to you. This for the payment scheme. The patient correlate by government office, by government has, this one is 532 times higher odds of receiving sorafenib rather than doxo compared with those who did not government receive payment from government. And for the second one about Firefox is about 5.89 times higher odds of receiving Firefox compared to doxo, compared to the patient who did not receive payment by government. As you can see, based on this one, based on the factor of health coverage scheme, it means that the patient who work on government like a higher chance to receive sorafenib, right? Because they can reimbursement compared to the patient who did not work in government. Because if they would like to receive sorafenib, they need to pay by themselves. But based on universal coverage, this patient can receive only doxorubicin, which is chemotherapy. Okay. And the next slide is like a other factor that we can fit in the model. This is about HCV infection. And then I'm still use the reference group is doxorubicin. It's up to the researcher that which one should be reference group of the outcome and which one should be reference group of the predictor. Okay, and this one that I get the odds ratio. The patient with HCV infection has 22%. If the odds ratio less than 1, it means less likely or like a low chance. 1 equal 1 minus like the odds ratio, we get 22% lower odds of receiving sorafenib. นะคะ rather than doxo compared to those without HCV infection นะคะ if the patient have HCV infection like a less likely to receive sorafenib about 22% lower compared to the patient without HCV infection okay this is compared to Firefox นะคะ if the patient have HCV infection like the higher chance to receive Firefox compared to doxorubicin right about 1.54 times นะคะ compare with those who did not have HCV infection so the main is like you need to think about the reference group of the outcome and reference group of predictor okay this is the real practice okay right now does anybody have question about when you will apply multinomial regression when will you apply multinomial regression ใช่ค่ะดูก่อนใช่แต่ว่า option is like RRR but the value that you get on the screen is odd ratio when you apply when will you apply multinomial model the outcome of interest is categorical variable and has more than two groups and you would like to identify the factor that associated with the outcome okay this is for the real practice that I would like to show you when you like have the question about determine or identify the factor that associated with the outcome the first table you need to show the baseline characteristic between different groups okay and for the statistical analysis we can apply the basic statistical analysis for example for categorical variable we can apply chi-square test or Fisher exact test and for continuous variable this is more than two groups you need to apply one-way ANOVA okay the first table I'm not emphasize about the multinomial model is applied for cross-sectional data just only measure one time just only the baseline factorนะคะ this is for cross-sectional data and then as you can see first you need to show the distribution of each factor among three different groups and then test by the basic statistic like a one-way ANOVA for continuous in case that there are normal distribution if not normal distribution this is like I try to record the previous concept basic statistical analysis นะคะ when you analyze the data or work on the research don't jump to like the final model you need to go step by step to describe the characteristic of the patient first and this aim you would like to look at the predictor that associated with receiving each outcome so you need to explain description like a descriptive information of characteristic among different group right and then compare with basic apply basic statistical test นะคะ and then the second table we need to show about the univariate for the univariate normally for logistic equation you have only odd ratio just only one odd ratio for each factor right but for multinomial you have the number of odd ratio equal number of categories of the outcome minus one for this example we have three treatment so you need to divide it into two panelsนะคะ in this case I use sorafenib as the reference so you need to specify at the beginning as like a doxorubicin versus sorafenib and Firefox versus Sorafenib. This is the result of univariate that we worked before. Fit each factor one by one, and then you will get like the odd ratio, the odd ratio for each factor. And then I would like to emphasize you that when you construct the table, first outcome you divided into the panel. The panel equal number of categories minus 1. Okay, this is 3 intervention. We have 2 panel, odd ratio, 2 odd ratio, okay, 2 panel. And then set like the reference is sorafenib. And for the predictor, the reference group should be the reference group, the odd ratio equal 1, should be in the last column of the category. No? And you show the first factor that I compare between region, central and north, because this project we perform multi-center study, and we divided the subject into like a center region and north region. And then we estimate the odd ratio for compare doxorubicin and sorafenib. And then compare Firefox with sorafenib. You get 2 odd ratio and 2 p-value. This is for univariate analysis. And based on univariate analysis, we will look at the p-value for each predictor. It means that at least one significant, at least one, this is like a 2 odd ratio, right? At least one odd ratio significant, we will select that variable into the multivariate model. Just only at least one significant, we will put that variable into multivariate model. And this is the final table 4.3 is like the final, no? Okay. And this is summary at the end, the final model that can put together. It means that all of them should be significant, at least one odd ratio. But as you can observe, this one for ECOG, as you can see that the p-value is non-significant for both odd ratio. But however, when we consider the factor in the model, sometimes we don't care. First, we focus on statistical significance, and some that is non-statistical significant and have like the clinical important effect. So you can put that variable into the model. But the condition is if that variable has like a clinical significance or clinical importance, and the odd ratio should be greater than 1.2 or less than 0.6. Okay, even though it is clinical important, but we need to consider the strength of association or the odd ratio too. The odd ratio should be higher than the level that we set. Normally, they recommend about 1.4 or 1.5. And for predictive, is lower than 0.6 with clinical importance. Even though it's non-significant, but the odd ratio is high. Because the problem is sample size. Some factor that is very important, but you cannot detect because the number of sample size is not the whole number of sample size, but the sample size for each category. For example, if you found like a rare exposure, not rare outcome, rare exposure. For example, smoking. That you can find like a smoking associated with lung cancer, right? But right now you have like a rare exposure. It means like the patient who smoking is very small. It means that you need large sample size. But if you have only like small sample size, even though it's significant, but you cannot see statistical significance based on your sample size นะคะ for rare event rare exposure or rare outcome the problem is sample size if your sample size is not large enough it means that you cannot detect statistical significance so we try to consider some factor that have clinical importance with high value of odds ratio
How important that is that?
we will not consider right now you understand how to when you apply the multinomial regression how to interpret the result and how to fit the model to get the odd ratio how to present the result okay I have an assignment for you based on this data set นะคะ based on data set that you work on I would like you to set baseline outcome as dorsal visit and fit unique variate multinomial model for the treatment assignment and then select only significant variable into multivariate model and then consider again after you put them all together and consider again if some is non-significant you can remove later นะคะ and then report the result in the table and interpret the result the way to report the result as I showed you นะคะ this is the way to work on okay and for the factor that I will upload the file that I prepare this is data dictionary นะคะ this is all factor that I would like you to consider เนาะ I tabulate for each variable this one I will upload this one นะคะ this is like a data dictionary to know that which one is like a variable this for cirrhosis this is for HCV infection I will put the variable name and the label and upload later นะคะ in this eveningอย่างนี้ but I'm not sure that move update on okay and probably some variable that not have the label or the meaning that you will put it in the table probably I will add more information about label for example BCLC CO EECOG something like this because this is the variable name not the variable label when you present the table as I show you when you work on analysis you focus on variable name right this is a small letter not more than 10 for variable name right but when you present on the table you need to put all information หมายถึงว่า explain the detail of that variable for example health coded scheme that the variable name is I set at HCS right but when you put in the table to present the result you need to put health coded scheme not HCS not put variable name but should put the meaning of that variable ค่ะ that is for multinomial that you will use this concept นะคะ in treatment effect model that you learn in the last course last two section นะคะ about treatment effect model นะคะ Yeah, okay. the table 2 and 3 is okay because table 1 I would like to show you just only the way to report the result. But however, for student from community medicine, you haven't studied about this before, right? Okay, this assignment should present only table 2 and 3. For table 1, I ignore, or probably for special for clinical epidemiology to remind your knowledge, no, about test for the basic. And for student from community medicine, just only table 2 and 3. And for clinical epidemiology student, you need to perform 3 table. Okay, finish about this topic. Okay. Does anybody have question about this topic, about this model?
When we use the command mlogis, it means that the starter, the program will create the odd ratio or anything with consider of other predictor variable already, just like that.
You mean like the outcome variable, right? For M logic. Now, normally for the command logic, it means you fit logistic equation. So for the outcome variable should be closed at 1 and 0. And when you apply M logic, the outcome variable have categorical variable that has more than 2 groups. And it can be coded at 1, 2, 3, 3, 4, 5 is anything that you can code. Not necessarily 0, 1, 2. You can 1, 2, 3 or 3, 4, 5, but it's very important to set the baseline of the outcome variable. If you haven't set the baseline group of the outcome, the data will select the most observation, the largest observation of that category as the reference group.
I don't understand about the homework. So first we have to do the univariate first. Then we go to the next step. That is the multivariate model.
And for first, you need to fit the univariate model that we work in this class, as we work in this class, right? And then you prepare the table 4.2 to present the result. And then you look at what variable that is significant. Even though just only at least one odd ratio significant, we will put that variable into the multivariate model. Okay. The same ค่ะ okay, for example, that right now I know that cirrhosis is significant, right? And another one is like a health correlate scheme. It means the multivariate is mean that we consider more than one predictor in the model at the same time. Okay, I try to fix M logic, based doxorubicin, and the variable that I put first is like a cirrhosis. And then I can add more variable. For example, like an I dot, health correlate scheme. Okay. health college scheme นะคะ and then enter okay this is called multivariate because in each panel you can see more than one variable right and the first panel is like a cirrhosis yes compared to the non-cirrhosis is significant the odds ratio equals 0.34 and for the second variable is about health college scheme is also significant okay in the first panel and then for the third panel this is the effect of cirrhosis and health college scheme that we consider both factor together ค่ะ or you can add more นะคะ and select only significant variable or statistical significant นะคะ because I would like you to understand how to select the significant variable in univariate analysis and put into multivariate analysis and after you put into multivariate analysis this is just only two variable right okay if I put more for example I put sex and then as you can see the result for the first panel cirrhosis is significant right cirrhosis is significant and then health college scheme still significant and sex even though univariate is significant and you consider in multivariate model and as you can see that when you consider gender or sex with other factor it become non-significant in both panel right the first panel is female is non-significant and the second panel is still non-significant. It means that after you consider from univariate and then put it into multivariate, like a consider with other predictor together, and then we found that this is non-significant both panel, okay, and then you remove it and fit multivariate again. And at the end, you will get only significant variable into the model. The significant in this condition, just only at least one odds ratio significant, we will keep it. Even though like a significant in panel of sorafenib, but not significant in Firefox, we will keep it. Because at least one odds ratio is significant, or at least one panel significant, we will keep it. But if non-significant for both, for all panel, we will remove it, not consider in the final model. Yes, that's right. In this case, I think just quick go you can use 0.05, but like that you learned already about stepwise analysis, no? I think that is like a complicated for the new student. I think this way is okay, no? Because I would like you to understand how to fit uni and how to fit the multivariate. But however, it's better if you can use the stepwise to select the variable first. But however, we need to start from the univariate model. To make it easy, it's not complicated. But all of you know the way how to select, like the process of select variable, like a stepwise. Backward, yes, select. Yes, that's right.
It's not the assignment, but then show that it's technical.
Yes.
And we see the effect.
Yes. In real practice, but in this that's only assignment. I would like you to understand how to fit univariate and how to consider the variable into multivariate and select only significant variable in multivariate model and then interpret the result.
It's the same result that if only one have two factors.
No, not necessarily for assignment.
I mean, for
Yes, that's right.
only one factor. In three, they have three, only one. Oh, factor one. Expensive, but have two.
And you can add more in the model.
Only one.
You mean like you can add
So they
Only
make
one,
selection, only one. Only one. Like so around in cases.
it's like a significant.
They went
Uh-huh.
like what? Concept on.
Yes, that's right. They're the same concept.
And we have to remove every factor.
First, like start with unique variate analysis to look at yes, about 10, and at the end, how many factors that you will put in the model. That's only statistical significance in the assignment นะคะ Because for consider clinical important that we need to discuss with the team and expert in that field
So you use it start up.
ค่ะ
Take it start up.
ใช่ใช่
I will do it.
ใช่เดี๋ยวพี่เดี๋ยว I will yes and I will select only 10 variable for you to practice นะคะ not go to like all variable and I prepare just only 10 or 12 variable for you to practice
And normally, how we do it now? For me, over two.
Over 2 it can be like 5 or 6 it can be but you have to have like the last sample size This is for treatment of SCC ค่ะ but I have experience for treatment of prostate cancer there are 5 groups of treatment normally the doctor classify as like the DAC class no that for prostate cancer we have about five category is about hormone is about อะไรorchiectomy อะค่ะ like many treatment for prostate cancer and I work on that with 5 group of the treatment and you have like a 4 panel that is very hard to look at for each panel that is more complicated but you can do if you have more than 2 even though 3 4 or 5 but if you have like a more category of the outcome you need larger sample size ฮะ I will give you a break about 5 or 10 and then we will start survival analysis okay I think it's better to give you 10 minutes because you have to download the new slide and new data set that MOOC that's uploaded this morning okay give you 10 minutes for a break okay and we will start with the new topic survival analysis but however in this afternoon if we can finish before 4 then it can be it up to you if you understand about the way to analyze the data that we can go fast and then can like finish early like finish earlier no okay. 10 minutes break and then come back
And if you say it from and then we got a pass the ball.
พูดตอนตอนตาย
ไม่ยาก
เอาท้องหน้าถึงมัน
นะ
ต้องคือเป็นไปแทนสิ่งแวดล้อมคนนี้ต้องอย่างเป็นที่ต้องของความรู้ต้องบอกตัวเองสิ่งเราบ้างความจริง Yes, yes. I embody that in what I feel my problem. Because it has a table motors, and I have to teach myself, but they I have a confidence to work and not really. Yeah,
อยู่หลาย
Are you ready? Shall we start? Next, I will move to the new topic that we call survival analysis. Today, just like the basic for survival analysis. Based on survival analysis, there are like 3 parts. Today, we will focus only the first part about time to event data analysis. And we prepare the data in just only 1 record per person. And for the second part is about time varying coordinate. In the second part, we will focus on multiple record per subject. And the same as the part 3 that we will work on multiple record per subject. But today it's just only the basic. Okay, we will focus time to event, the basic of time to. I divided my talk into 5 sections. The first section is about introduction of survival analysis. And then we will look at the concept or the feature that you need to understand for survival analysis. And then we will estimate the survival parameter and then compare the survival curve. And at the end, we will apply complication model to look at the effect of the factor to the outcome. Right now, the outcome of interest is time to event. For the previous 2 topics, we focus the outcome is just only event. But right now, we consider time to event. Okay, I would like to go to the first part, that is introduction of survival analysis. Okay, that I emphasize when true several analysis is used, the outcome of interest is time to event, and the study design is randomized controlled trial or cohort study. Just only these two design that you can apply the outcome like the time to event outcome. This is for the first example about the cohort study in advanced SCC, the same as the previous data set. The aim of the study is to comparing 5-year survival after receiving chemotherapy versus multi-kinase inhibitor that we learned before. The outcome of interest is time to death after receiving treatment in patient with hepatocellular carcinoma. Every time that you read the article, you need to, even though you conduct your study, the important thing is PICO. According to this question, you need to answer by yourself. What is the P? What is P? In this one is advanced SCC, right? Is the population. And for intervention and comparator, in this case, is exposure is non-exposure, which is multi-kinase inhibitor compared with chemotherapy. And the outcome of interest is time to death. Okay. Study design is cohort study that I forgot in the first slide about study design. Okay. And the second example is about the cohort of renal transplantation. Every time that you talk about the cohort, you need to know that which cohort. Like the cohort is the group of patients that has like the same condition. For the previous example, the cohort of advanced SCC, it means that the patient who have advanced SCC, this is like the same cohort, right? The same, like the same disease. And at the beginning, the outcome of interest is time to death. It means that at the beginning, nobody have the event at the beginning, and we need to follow up until the event occur. For the second example, the population of interest is the cohort of the patient who perform renal transplantation, and the exposure or the factor of interest is CKD and LRKT. CKD and LRKT is like a cadaveric kidney transplant, no, and living kidney transplant. This is type of donor. Kidney cadaveric and living related cadaveric. Living related kidney transplant and kidney and I cannot remember. CVKT is like a from the dead patient. Is for kidney transplant, and the outcome of interest is time to graft rejection or graft failure after perform renal transplantation. Study design is cohort study. We start from the date that patient perform renal transplantation and follow up until the event occur, which is graft rejection or graft failure. And the third example is RCT. No? The researcher would like to compare the effect of the treatment, which is tacrolimus and MMF. The subject is the patient who died at lupus nephritis. And after they die at, they will like prescribe the treatment, right? After receive the treatment, the doctor will follow up and look at disease remission that we call time to remission. Time to remission after receiving treatment. Okay, you need to know like the start when you calculate the time. You need to know date start and then date stop. Okay, that I will explain later. But based on 3 examples, you need to understand about the event of time to, the outcome of time to event. No, we need the follow-up time. Okay. Based on thermal analysis, we need to perform the Kaplan-Meier analysis. And then we will go to the semi-parametric approach that we call Cox regression model to estimate the hazard ratio. But for parametric method, we haven't focused for this class. Right now, I would like to focus only on parametric approach and semi-parametric approach. This is I summarize for the type of survival analysis that they are can divide it into 3 conditions. The first condition is single record, single event. The meaning of single record is mean that you collect the data and prepare only single record. For the follow-up event, you can summarize. For example, the first patient who have date of renal transplant, right? And then you follow up and then you collect only their last follow-up or their event occur or not. Like a summarize event occur or not. If occur, when the event occurs, specify date of event. And in case that the patient haven't event occur during the study period, you need to have a date of last follow-up. It means that follow-up data, but we prepare the data just only single record per subject. You have to prepare a start date, end date, and event yes or no. And the event that we are interested just only single event. The example that I showed you before about renal transplantation, we look at only graft rejection, not focus on a death or other outcome. For example, hospitalization, severe infection, we haven't focused on that event. Just only focus on only one event or single event. Type of analysis that we will learn today is Kaplan-Meier and Cox regression. But for the second condition, this is we collect the data as multiple record per subject. It means that you need to record every time that the patient visit to the hospital. And then sometimes the drug is changed every time that the patient come to the hospital, right? And the doctor change the medication, or even though the laboratory result, their laboratory result change anytime, and we will collect anytime that the patient come to the hospital. And however, the event of interest just only single event. So we will consider about time varying correlate. For example, about renal transplantation, we look at the outcome is time to graft rejection, right? But during the time that the patient follow up, the doctor will prescribe an immunosuppressive that change anytime that the patient visit, right? Or other example is a graft function that we consider about creatinine that change over time, not stable, right? Many factors that change over time, we can, the benefit of the second approach is we can consider the factor that change over time in the model. But for the first condition, we focus only the baseline factor. So that I will explain later why if multiple record is better than the first one. But however, we need to understand the first condition and then move up to complicated model. And for the last one, this is the same as previous as a multiple record. But the event of interest, we have a many outcome of interest, more than one event. For example, multiple event, we can divide it into same event and different event. For the same event, as example that we give the treatment to the patient, right? And look at disease remission. And after that, after remission, and you follow up the patient, and then they like a relapse, and then remission again. Like a can be like a remission, relapse, remission, and relapse. It can be like many disease remission, right? More than one time. That we call multiple event, like a same event and multiple record. Same event with repeated occur. And for the second condition, is like a multiple event with different event. For example, we are interested about graft rejection. And during the time that we follow up, the patient have severe infection, or even though have like a death before graft rejection. That we call different event that can occur during the time of follow up. We will apply this one like a multiple failure model. So today I will focus only the first one, single record and single event. Okay, the second topic that about feature of survival analysis. When we would like to conduct the study and apply survival analysis, you need to understand like the important factor or important function that you need to collect and consider. The first thing is the patient must be free from interested event at the beginning for cohort study, or even though for RCT. If you interested time to event, it means that at the beginning, the patient have to free from interested event. And then the second issue, you need to define the patient status. If you focus on dead or alive, or infection or non-infection, you need to know about the patient status or outcome of interest. And the third issue is about time to event. You need to know how to define time to event. For define time to event, you need to specify what is your start date and what is your end date. Okay, I go into detail for this point. Okay, this picture is like the way to explain about survival analysis that we follow up the patient. As this figure, interested event, as you can see on the figure, is like an event, right? For the third patient, third patient, interested event, it can be dead or recurrent, and another term that you need to know is about censoring. The censoring is like the event, the patient that the event not occur during the time of study. That it can be lost to follow up, or even though withdraw or terminal from the study, or have other event that you are not interested, that we call competing list or competing event, and then not have event at the end of the study, that we call censoring. It means that right now you know about all patients need to have the status event or censor. Censor it means non-event, and non-event can cause by lost follow-up, withdraw from the study, have other event that not interest, and not the event not occur at the end of the study. All of these condition has no event. The patient who have no event. Okay. And I have the picture for this one. Type of censoring. There are many types of censoring. The first one we call light censoring. This means like the subject is dropped from the study before the event occur, or we can say lost to follow up. We don't know because they lost to follow up and we cannot detect the event because the patient lost to follow up. We call light censoring. And the second, this we also call light censoring because this subject event not occur during the study period. As you can see in this picture, the first line, that this is the starting point. Okay. And then the second line is like the end point. This we call the duration of study. So the patient come to the study, enroll to the study at the starting point, and then follow up until the end of the study. And this patient follow up until at the end of the study, but haven't event of interest. Okay, they call this light censoring. And for this case, if we call left censoring, it means that the patient like a event occur during the time of follow up, but we don't know the date start, exactly date start, so we cannot calculate time to event. Normally in this case, we will remove these two patients from the analysis because we don't know when they start. But we know that after follow-up, the event occur, but we don't know the beginning point. Therefore, okay, this is an example of cohort of study renal transplantation. Patient is mean like a cohort of subject. The patient here is renal transplantation. The patient status can be divided into graft rejection. This is the patient status, graft failure. And for non-event, or the term that we call censoring, is like the patient who did not have graft failure at the end of the study, or some patient lost to follow up, that we call censoring. And for calculate the time, we need to determine date start. Date start is date of kidney transplantation. And end date. End date can be divided into end date depending on the patient status. If the patient have event of interest, we will specify time to date of event. In this example, this is date of graft failure. In case that the patient do not have graft failure during the study, we will use date of last follow-up. Okay. It means that when we calculate the time to event, it depends on the date of end status, the date of the end date is depend on the patient status. This is the second example about the cohort of advanced SCC patient. The patient is advanced SCC. The event of interest is date. So patient status can be divided in date or censor. Censor is mean the patient still alive at the end of the study, or lost to follow-up, or withdraw from the study. And for the third section is about time. Date start is date of receiving treatment. End date, if the patient die, the end date is date of death. If the patient still alive until at the end or lost to follow-up, we will specify last date at the last follow-up, date of last follow-up. Okay. When we analyze the survival analysis, you need to specify the study period. The study period equal recruitment period plus follow-up period. There are two periods. So as you can see in this figure นะคะ accrual is the meaning as the same as recruitment. So they specify like the recruitment period start from 2000 นะคะ until 2003. This we call recruitment period. It means that we will recruit the patient start from 2000 until 2003, and then and then you stop to recruit the patient, and after that you will follow up the patient until the end of the study. Why we need to determine the recruitment period? Because we would like to specify the time follow-up. If you haven't specified the end of recruitment, you will recruitment until the end of the study. It means that the last patient haven't time for follow-up. Normally, the researcher need to specify time for follow-up to like an event occur. For example, some studies say that at least the patient should be followed up at least 1 year. It means that the last patient should be followed up at least 1 year. And for this one, that's why we need to determine the recruitment period. And then the rest is follow up until the end of the study. In this figure นะคะ we use cross symbol as dead and like a dot นะคะ as alive. As you can see from this from this figure นะคะ on the left hand side, when you determine the recruitment period, it means that the patient can come anytime during recruitment period, not just the same day, not necessary to come in the same day, no? But you specify the time frame, the recruitment period. It means that in your left hand side, the patient can come anytime before end of recruitment period, and then follow up until at the end of the study. นะคะ and the middle figure show that this is the way to analyze the data. We need to calculate time for each patient. In this figure, we have 6 patients, right? For the first patient, you need to calculate the time. ID1, time to like a time to event. It means this you 7 years, no? And you need to know about the status because you know the starting date, right? And then end date. So you can calculate the time. And the first patient status alive. For the second patient, calculate the time equals 6, no? And then dead. And then the third patient, the time for follow-up is 6. Even though the day that they recruit is different from previous 2 patients, right? Because they enroll in the different time. But however, when we measure time to event, because this patient alive, we get 6 years, no? And number 4, number 5, number 6, all of the patients have specific time. Calculate from the start until end date. And then you need to know about the patient status. In this case, the outcome of interest is time to death. So the patient have dead or alive. นะคะ This is the way to prepare the data. Okay, and this is another example. นะคะ The same as you can see from the picture. We have 2 periods, right? Recruitment period or accrual period, and then study period. Okay, and the symbol for D for death, A for alive, L for follow-up, and W for withdraw. It's not necessary to specify patient status as dead and alive. You can specify other conditions, loss to follow-up, withdraw from the study, any cause that like occur during follow-up time. นะคะ So this is for 10 patients, and this is another way to collect the data. They start with the enter. Enter is 1.5 and then end with 5. This is the month นะคะ time is month. The first patient come to this study in like a 1.5 month นะคะ and then follow up until 5 months. So you can calculate the different time between enter and end. This you will get 3.5 นะคะ time to enroll in the study until they withdraw. Status is withdraw. For the second patient, the same. They come to the study in the first month and then follow up until 9 months. And at the end, they withdraw. We can calculate time from start to withdraw, which is 8 months. นะคะ Okay, this is the way to manage the data. Okay. All of this, like the feature of serval analysis. If you like to perform serval analysis, the important thing is you need to collect date start and date stop. And they stop depending on the event occur. นะคะ That I have experience with residency training. Some residents come to me and then they plan to perform serval analysis, but they haven't collected last follow-up. It means that we cannot do that, right? Because we don't know the time for all patients. Okay, that I let them go back and then try to find date last follow-up, and then should be specified date of like a end of the study. For example, if I set the end of study is today and outcome of interest is date, today the patient is not, today the patient still alive, today it means that their status is alive. Even though tomorrow they die, we don't care because this is out of study period. That's why we need to cut off for the study period. If you haven't set exactly the end of the end of the study, it means that you don't know how you follow up the patient until forever. We don't know, no? We have to cut off so they can so we can specify the event occur during the study period. After the study period, even though the event occur, we don't care. We say that that patient the event not occur during our study period. However, the important thing is follow-up time. Follow-up time is depend on the content or the disease that you are interested. For example, if you are interested in like a time to date for this case, but you follow up the patient only 6 months, like a follow-up period only 6 months, it means that you will like a small amount of the event, right? It depends on follow-up time depend of the event that you are interested, how long that it can be occur ค่ะ no? So you need to clearly specify time of follow-up. And for some time, for example, in gynecologist about pregnancy, probably like a follow-up time just only 9 months, or even though 6 months during like a pregnancy, something like that. It depends on the content. Okay. After you understand the important figure or important feature that you need to consider during conduct the study, and then next step we will go through how to estimate the parameter of interest in serval analysis นะคะ Okay, I will start with the process, the concept of Kaplan-Meier analysis. I think all of you can like have experience to see this figure, right? This we call Kaplan-Meier curve. No, based on the Kaplan-Meier curve, we need to know about the survival probability, and then you need to know about the median survival time and the incidence rate. I will go into the detail about each value each parameter นะคะ and another thing that I would like to emphasize is for serval analysis the outcome of interest can be any not only date นะคะ because when we talk about serval analysis just the basic the event of interest is date but nowadays the event of interest can be infection graft rejection or disease remission or disease relapse it can be any นะคะ for example or for another example is disease progression เนาะ you can focus on time to disease progression and when you plot the graph you can do both the graph Kaplan-Meier for time to disease progression or in opposite time to disease free อะค่ะ or progression free เนาะ okay that I will go into detail เนาะokay this is the way to calculate the Kaplan-Meier curve นะคะ first we need to at the same that explained before we need to know about the time that the patient come to the study นะคะ all of the patient have a specific time and then have the status this example focus on outcome of death นะคะ the first patient enroll into our study and they die in the third month นะคะ and the second patient come to our study and they alive and like stay in our study 4 months เนาะ okay and for the concept of Kaplan-Meier first it the table in your right hand side นะคะ they try to source the time from smallest to largest and then as you can see the number of sample size in this case is 10 so at 3 months all of the patient record number at least is 10 and then one patient die at 3 months and how about number of sensor no sensor right because one patient die at 3 months and then for the second row 4 months at 4 months how many patient like alive until 4 months is only 9 right because one patient die at 3 months for 4 months it remain only 9 patient number at least is 9 and how many patient die at this time no patient die in this time 0 and number of sensor is mean like alive still alive in this month right number of sensor equal 1 because just only one patient that have follow for 4 months นะคะ just only one patient right one patient have 4 months and this patient นะคะ all of this only one patient number of sensor is mean alive because number 4 months as you can see for 4 months the second number 4 months and they still alive right so number of sensor equal 1 and then the next time is 5.7 it remain at this time it remain only 8 person right because 2 of them like quit or stop or like out of our study is remain 8 patient and in this patient just only one patient alive right and then when you go to the time 6.5 as you can see there are 2 patients right at the same time it means that the number of patients still remain 7 and how many patients die 2 patients die and 0 patient alive นะคะ and then move to the next time 8.4 the subject remain 5 because some of them die and some of them lost to follow up not go into 8 months right and this is alive นะคะ this patient alive and then go to 10 like a month 10 months the patient remaining number is only 4. And as you can see, one of them die and one of them survive. It means that the number of death equal 1 and number of sensor equal 1. This is the way to change the individual patient data that you collect to the Kaplan-Meier table. But however, I would like you to understand, but not let you do by manually. Just let you understand the concept. Okay. And based on this table, we can estimate the probability of death at time t for each time frame, for each time point. For example, at 3 months, you know that 10 patients still alive at 3 months, and one of them died. The probability of death equal 1 divided by 10, right? Equal about 10%. And at 4 months, no patient die. It means probability of death equal 0. No? And 5.6, okay, 0. And for 6.5 months, 2 patients die, and the number of risk, like the number of patients that's still alive, divided by the number of patients that's still alive, we get 28.6 probability of death. Okay, this means that we calculate the probability of death for each time point. Okay. And after that, we need to calculate time to survive. Time to survive is 1 minus probability of death. Okay, so probability of death at 3 months is 10%. So the probability that survive after 3 months is 90%. Okay, 1 minus probability of death at that time is probability of survive at time t. And after that, we will calculate that we call cumulative survival function. As you can see, at 3 months, the survival probability equals 0.9, right? And then for 4 months, the probability of survive equal 1. So we multiply, multiply the probability of survive of previous time and then current, that we call cumulative survival function. And for 5.7 months, the first one is the probability of the probability at 5.7 months, and the second number is the probability of survive at 4 months, and 0.9 is the probability of survive at 3 months. So we multiply. It's called cumulative probability function. That we call the probability that we get is called probability of survive longer than time t. Okay. This is the way to interpret the result. So based on this information, we can estimate the median survival time and the probability of survive longer. So as you can see, the median survival time is the point that 50% of patients can survive longer than what? Longer than 10 months. You try to define the probability of survive at 50. So when we interpret the result, it means 50% of patients can survive after or longer than 10 months. Okay. This is the Kaplan-Meier curve based on probability of survive. And as you can see, when we plot the graph, the Kaplan-Meier curve on the y-axis is the probability of event, in this example is probability of survival นะคะ based on the previous table อ่ะ this table you convert the information from this table to Kaplan-Meier curve นะคะ so the y-axis is the probability of survival the x-axis is the time so that we set like a time from 0 to 15 months นะคะ and then calculate the probability and then can show the plot and based on the plot you need to like draw the line at 50 percentile or 50% of probability of survival and then you draw the line นะคะ until you like until it's crossed with the survival curve อะค่ะ and then you draw the line like draw the line in direct like down to the x-axis and then at 50 percentile probability you will get 10 months this mean median survival time it means that 50% of patients survive longer than 10 months okay this is the same convert from the table to the survival graph นะคะ the first thing that you estimate the median time right this one the outcome of interest is death so this part the median is median survival time if the outcome of interest is disease progression if you plot like a free disease progression นะคะ this is like a median time to disease free or free disease free progression นะคะ okay I have another example okay the next parameter that we need to estimate at incidence rate the incidence rate is different from the risk of disease the list of event the risk is mean like a number of event divided by the number of subject at that time that we call risk of disease but for rate the rate it mean like the incident as you can see death rate is mean number of subject who die divided by time at risk นะคะ okay so it means that for this time at risk is mean like you calculate it mean like you sum up the time of all subject that we call time at risk this is for 10 patients right the first patient still in our study 3 months the second 4 months we will like a sum all time of 10 subjects and then you get 81.1 okay so the incidence rate equal the number of events divided by time at risk the time at risk come from sum up all time of the patient that you can get time at risk and then you estimate the incidence rate and when you interpret the result death rate equal this one is the death rate equals 0.074 right if you multiply by 100 you can get 7.4 or it's around 7 so you can say that the death rate is 7 patients per 100 patients per month it depends on the unit of time if you use unit of time is year this is per year or in this case if I multiply by 1,000 how many subjects that I get 74 it means death rate is 74 patients per 1,000 patients per month it's called incidence rate Okay, right now you get the median time you need and you get survival probability for each time point and then get the incident rate. Okay. Right now you are understand the concept. Next, I would like to move to how to perform in the data program. Okay. In the data program, we have 4 steps. The first step, you need to declare survival time data. And the second step, you can estimate incident rate and median time. And after that, you can estimate survival probability and construct Kaplan-Meier curve at the end. This is 4 steps to perform the Kaplan-Meier analysis. In data now. Okay. Next, this is all command that I prepare for you to do like perform each step. Okay. This is just summarize na. ST set, ST sum, ST rate, ST CI, ST SF, ST S star. However, we will work on together one by one. Okay. We will start with ST set first to declare the survival time data. Okay. However, we have like a case scenario has many conditions to set or to declare the survival time. Okay, I will go to the first condition, single record per subject and record time without censoring. It means that all patients die or have event of interest. Single record per subject and then record the time as time. It means that the researcher calculate time for each patient already. Record time without censoring. Okay. Go to the first condition. And I note at the bottom of the slide, you need to open the file EX1 Single record survival time data without censoring. Single record survival time data without censoring. If you still in the previous data set, please type clear, or you would like to save before you leave. And then clear is mean close, and then you open the data. Okay, I prepare for you like a file, no? As you can see, example 1, 2, 3, 4, 5. First, I would like you to open example 1. And as you can see, the data has only 3 variables. You can type the command risk without variable because there are only 3 variables and the number subject only 10. No? But if you have more than that, you need to specify, no? Just only list in 1 to 5 or 5 to 10, something like that. And then just only 3 variables. You use the command risk and then you can see this is the data that you need to declare. First variable is subject ID. That is very important to refer to each subject. And then the second variable is time. And you need to know like a time in month or time in year. All of record should be the same unit. You need to convert to the same unit before you analyze. And then the last variable that is like the patient status. But for this study, all of them die. นะคะ but different time okay first I would like you to tabulate look at the incident of like a death rate or like an incident rate first okay tab place and then enter you mean that 10 record all of them die นะคะ okay first we will apply the command stset to declare the server data you use the command stset followed by variable time and then comma specify the failure variable which is the variable date okay or probably does only stset time but I suggest you to comma and then specify failure date and after that you enter okay the output that you see on the screen will show the detail of the server data like the server data so as you can see they say like the number observation this one the number observation 10 observation and then 0 exclude it means that all record can like calculate the time and then 10 observation remain for analysis and 10 of them has like a die right all of them die and 82 total analysis time at least this is they call like a summary or time of the patient 82 is like a time at least and then you look at last observation exit it means that the maximum follow-up time is 12 as you can see for this one 10 subject the subject that like follow up like longer than other the maximum is 12 this is you need to know that the time that you collect is like a unit is month or year this is the way to declare data and after you declare the data you look at the variable window you can get the new variable automatically in your variable window can you see the underscore st this variable mean 1 if record to be used and 0 if ignore it means that how many record that can apply for analysis because sometimes the time is like a negative value for example some record as time is negative underscore st equals 0 because cannot apply for server analysis because time to event the duration of time should be positive value right and if sometime you got like a negative value it means that that record will be removed from the analysis the variable underscore st will equal 0 I have the example for you and then another variable underscore d this is the same as the variable failure date 1 for event or 1 for failure and 0 for sensor and another variable is underscore t underscore t is like a analysis time when record is in it mean like a time for each subject and time 0 is mean like the beginning time for this condition all of the time set at 0 and then follow up unto underscore t this is the new variable that like generate automatically after you apply the variable st set okay after you get this one you get the new value right you can tabulate underscore t tab and then select the variable and then all of record equal 1 it means that you will use all record for calculate right and then for underscore tab underscore d will report number of interested event which is 10 all of them die next I would like to show you what command that apply for estimate the incident rate and median time okay you just use the command stsum and then enter ค่ะ okay you will get all information นะคะ time at least 82 it mean like a sum all of time right sum all of time for all subject อะค่ะ time at least equal 82 the death rate equal 0.12 you know that how many subject die นะคะ 10 ใช่ไหมคะ you can type display is like calculator data ค่ะ display 10 number of event divided by time at least and then enter and then this value equal incident rate okay event divided by time at least is called incident rate okay and then they explain number of subject 10 subject how you interpret the incident rate ค่ะEmma would you use microphone how to interpret incident rate
Oh, there would be 12 deaths among 100 patients in a month.
per month
Per month.
okay 12 patient per 100 die per month yes that's right okay very good นะคะ and the median time นะคะ median survival time equal 8 because they show survival time 25%, 50% and 75 median survival time is 50% right the probability of survive long like a 50% of patient survive longer than 8 months this is I show in the slide นะคะ median time and if you use the command stsum you will get all of this information median time and however if you use another command stci you will get median time with 95% confidence interval of median time that is very important when we report median time we need to report 95% confidence interval no you can use the command stci and then you will get median time with 95% confidence interval and the blue letter that is the way to interpret the result นะคะ 50% of patients can survive longer than 8 months okay with 95% confidence interval it means like the patient can survive longer than 4 to 10 months the next command is st-rate the command stsum give you an incident rate right but if we need 95% confidence interval of incident rate you can use the command st-rate นะคะ just type st-rate and then you can get rate no and then lower and upper is refer to 95% confidence interval. And they explain note like a event failure divided by person time นะคะ lower and upper are boundary of 95% confidence interval. Death rate is 12 per 100 subject per month. Okay. Next, you can estimate the probability survival probability by using the command STS list. You will get the output as I show on the screen. Try STS list. Have you got the result? No, as you can see, it's, the time is sorted by smallest to largest, and it show it's the same like Kaplan-Meier table that I showed you before. And then this survival function. The way to interpret the result is probability of survival longer than 4 months is 90%. Okay. Probability of survival longer than 5 months is 80%. Okay. Try to identify estimate the probability of survival longer each time frame, each time point. Okay, and next, you can construct the Kaplan-Meier by using the command STS graph. And then you can, this is, I make it by myself, draw a line. I draw it by myself, but in your computer, you can see only Kaplan-Meier curve, no? But, and you can guess that, you can define the median time by use this process, use this diagram. And then the previous that you use the command st risk, you can get the probability of survival, right? And if you use the command st risk comma fail, it means like show the probability of having event. The previous show the probability of free event of interest. Okay, the probability of survival or probability of event free. Okay, and sometimes if event of interest is not death or disease progression, sometimes it's like, for example, graft failure. It's very hard to look at the survival of free graft failure, right? Sometimes they can show the probability of graft failure for each time. No? In this case, now if you STS rate comma fail, the probability that you get, as you can see, failure function, no? Probability of survival is 90%, right? It means that in 5 months, probability of survival is 80, but the probability of death after 5 months is 20. When you interpret the result at 2 ways, it depends on what do you want to present. Probability of free event or probability of having event. Okay. For this one, it means like a probability of death after 5 months is 20%. But if you say the probability of survival longer than 5 months is 80%. Okay. It depends on what you are present. And when you plot the graph, you can STS graph and then comma fail. You will get the probability of event, okay, and get the median time to death. It's exactly the same. just only change probability of survive and death but however the result is the same the median time is 8 no exactly the same okay this is easy because I think the command is like not complicated now to declare survival data but the keyword is you need to understand what feature that you need to consider before you conduct the study what variable you need to collect what condition that you need to specify at the beginning recruitment period follow-up period and know how to collect the data and interpret the result what information that you will get median time incident rate probability of having event or probability of free of event okay? Right now it's 12 I think this is beginning that if you understand that you move to another case scenario I have 5 case scenario but at the end this is just like an overall but at the end we need to compare export and non-export no survival function between export and non-export as you see in the graph that not only one line right there are more than one line it depends on how many exposure group do you have that we will learn in this afternoon okay 1 hour and we will come back in a second scenario นะคะ before you leave does anybody have question รูปใช่ไหมคะเซฟรูปใช่ไหมอ๋อเซฟรีเพลซได้เลยค่ะหมายถึงจะเซฟเพราะว่าเวลา it mean that when you use the command st save you will get the new variable right if you would like to keep it you can save type save comma replace and the next time that you will like further analyze no need to start with st set อะค่ะ just come back and st sum st test something like that นะคะ replace I think replace is better or do you want to save as another file like the original data and then save as like the data that you declare the data that you declare survival time already no it's up to you can replace or like a save as because when you use the command st set you will get the new variable right so you can use the command after st set st sum stci after that but if you close without save it means that every time that you come back you need to st set again but if you save after you declare the data and you save it when you open next time you can use the command after st set not need to declare again okay 1 hour and you come back with anotherนี่นะคะ see you on one o'clock okay yeah time for lunch
ไปดี is beside the motion. There's like additional words we don't have to.
มันมีอินเตอร์คอร์สนะ6แล้วก็วันนี้มันมีอินเตอร์คอร์ส6เดือนของเดี๋ยวนั้นจะต้องเปิดไปคิดไปแบบเข้าฟังเฉยๆถ้าอยากเข้าถ้าอยากเข้าเป็นสามารถเก็บแอนซีไม่น่าถ้าเป็นข้อเป็นอุปกรณ์ไปกินข้าวใช่ไหมไปด้วยกินหูฟังก่อนของอะไรอ่ะรามาสองรายใช่ไหมรามาสุภาลักษณ์สีวันท้ายที่เป็นเหมือนเราขอแจกเงินคนก็เป็น But
เ ถ้าเราไม่ต้องเข้านี้ไม่ทำกับเขาไม่มีใครเข้าไม่มีใครเข้าหรอกเต็มบอกคิดว่าที่ทุกเข้าส่วนฉันขอไปหาสะพานเขาอะไร
ฮัลโหลป้าเลียอ๋อได้ค่ะของไปส่งแล้วเนาะโอ้ no people เอ้ย I want to go like what can I add so healthy What is this? So that Sarah. You want back now?
มันตกเพื่อนไงอ๋อเขาบอกเขาบอกอะไรเท่าไหร่ไม่อ่ะหนูเลยน่าไปด้วยอ่ะ
ไม่รู้ทำอะไรเลย
เปิดให้เราทำที่ไหนสักเป็นที่บอกถ้าเราที่ไหนเปิดให้ความรู้
แต่เราไม่ต้องแต่เราต้องสั่งซื้อถ้าเราไม่ได้บอกเลยเราไม่ได้ความไม่มา
หนึ่งของเราจุดที่มาสนใจโตของชีวิตก็ให้ผมสรุปให้
ใช่ผสมแป้งมันไม่กินมันทุกคนเลยยาเต็มทิ้งเลยลูกไม่ผมว่าพี่จำได้ไม่เลยผมว่าพวกเป็นกาวไปคอยพูดถึง
เพราะเราไม่ไปวางสูตรมันจะเป็นระดับ
ว่ามีเวลาเราที่เคยไปให้ผมลองใช่ไหมโอเคผมก็บอกคุณ
Okay, shall we start? You continue for further. Okay, for the second scenario, it's the same, but there are like a event and non. Okay, I would like you to open the example number 2. Example number 2, simple record several time data with stenciling code. And there are only 10 records. And after you open, you need to clear the previous file first and then open the new one. And after you open the file example 2, you can use the command list and then you can see like the output on your left hand, in the same line on left hand side. Right now, you can see that there are the patient with event and non-event, right? Could you please type date how many patients die? Six, right? 60% of patients die. The command for survival analysis, the same, start with ST-SAVE and then follow by variable time. This is variable name is time. If I change the variable name, it's like after, for example, duration. You need to ST-SAVE and then duration, no? It's variable. And then comma, and then you specify failure. In this case, the variable date, and then equal 1. Need to specify the date equal 1. And then enter. As you can see that there are 10 observations and then 6 failure. And then 81.1 is time at least. The maximum duration, like the longest follow-up time is 15 years. And you will get the new variable in the variable window. And after that, what you will do next? To look at incident rate, median survival time, and the probability of survival. Or just only median and incident time first. Can you remember what the command? ST-SUM, yes, ST-SUM. How you interpret the result, incident rate. Incident rate. How many people?
7
7 people per 100 per month. And how about median survival time? 10. It means that 50% of patients like a longer 10 months. Okay. And in case that you like to look at the 95% confidence interval of median time, STCI. And if you like to look at the 95% confidence interval of rate, ST rate. Okay. And then if you would like to look at the probability of death, probability of survival for each time point, STS and then risk, right? You can see like the probability of survival. But if you would like to look at the probability of death, and then you specify, yes, fail, no? You will get like the probability of death, and then how a curve, LTS graph, no? You will get the survival function, but if you STS graph, comma fail, you will get the failure function, okay? Okay, this is the second scenario that I give how to explanation for you in the slide. Okay. And next, the third scenario is the same, single record per subject and record time with censoring. But however, the code for the event is not 1 and 0. The event is 1, 2, 3, and 4. Okay. I would like you to open exercise number 3. Exercise number 3. Please. Okay. How only you can record, and then this. As you can see, the variable event, 1 for withdrawal, 2 for death, and 3 for last follow-up. So you can set ST set, right? Followed by the variable time, no? And then specify failure. The failure, what the failure? The variable event equal to, yes, that's right. If you tabulate the variable event, how many patients die? How many patients die? 4, no? And when you set survival time, declare survival, you can see 10 observation remain in the analysis and 4, no? Failure, it means 4 patients die. And then the last follow-up equal 9 months. Next, could you please give me the number of median survival time and death rate? What is the median time? 8.5, no? About 50% of patients has like a survive longer than 8.5. And incidence rate, 6 person per 100 person per month. The rate is like exactly the same, no? That after declare the survival, you can estimate median time, estimate incidence rate with 95% confidence interval, estimate probability of having event or having free event, event or free event, you can do both, and then construct the Kaplan-Meier. Okay. Okay, I will move to the next scenario that is more complicated, but I think this is like the real practice, because when we collect the data, we will collect date of start, no, and then date of last follow-up and date of event. This is the real practice, but sometimes normally like you calculate the time and then you can set as we discussed before, no, but in this case that the way that we collect the data is not time, but we have the variable for start date, end date, and date of event. Okay. Please open the file example 4, single record, single event for HIV project. Example 4 for HIV project. cannot use the command list now because there are many variables. This is the real data set that we work on. Okay. If you want to know how many records are there, you need to use the command count. Type count and then enter. How many records? 235, right? This is condition for single record per subject. So before we start to analyze the data, you need to check duplicate record first. By using the command duplicate tag and then subject ID. Duplicate tag and then subject ID because we would like to check that there are duplicate in terms of subject ID or not. And then you comma generate new variable. I said dup ID. Because this for single record per person. And then enter ค่ะ Okay. And after that you will get the new variable, right? As dup ID. You need to tabulate dup ID. Okay, to make sure that all record that just only have one subject. Okay, one subject per record. And in this database นะคะ we have date diagnosis, end date and outcome นะคะ Date start is date diagnosis and the last follow-up is end date. The outcome variable has date, lot to follow-up นะคะ 1 and 2. Okay. I would like you to describe. Describe it means look at the type of data, date of diet. And probably we can describe date diet, end date, and then patient status, the three main variables, and then enter. As you can see that date diet and end date is string variable. No, it means that we cannot use this command to declare because it's string variable. We need to change it to date format. Okay, I would like you to list to look at how they store it, the date นะคะ date date and then end date and only first 5 record. Okay. As you can see, this is day, month and year, right? Day, month, year. This is look like date format, but however, it's stored in the the format is string that you cannot declare survival. So the first step, you need to change the string format to date format. The command that I prepare on your right hand side. The first step, you need to convert string date to date format. The way that you change, this is like the function นะคะ Gen new variable I set date dxn นะคะ equal function date and then open parenthesis date dx like a string variable and then comma and this is like a in quotation mark day month year but year is because this study has like a year before 2000 and after 2000 that's why we need to specify to change the date format นะคะ as like a before 2000 and after 2000 after year 2000 and before นะคะ so that's why we generate date dx underscore n is like a new variable equal function date and then date diet like a string date comma and then all of this that you put in the quotation mark and exactly big D big M and 19Y okay we can do it together okay you generate นะคะ date dx new equal function date okay and then follow by date dx that is string variable and then comma and then after this is like the format that you want it's like day month normally day month year but we have like a 19 นะคะ before 2000 so we need to specify 19 and then enter and then close parenthesis okay and then enter and after that I would like to show what the result look like you list subject and date dx string and date dx new in 1/5 and then enter this is the result that you get right because this is like the format for like a programmer ค่ะ computer that is work to change string to date format but however this is we cannot understand because this is the computer language so the next command so we use the command format format variable date dx new and then %d to change computer language to the user language format date like a date format and then %d and then enter and after that you read it again the previous command to look at how they change and as you can see you need to look at on the first and second variable to 11/1990 right and then to November 1990 to look at this is change from string to date format okay and next I would like you to select in case that if date dxn that we generate still missing cannot change because we change only from the year before 2000 right but the year after 2000 we need to replace later okay with this condition นะคะ and then okay this is all like a year is all of them is before before year 2000 how we can check that the year is correct I will split only the term of year into the new variable นะคะ gen year dx equal year of date dx new I would like to check that the year is correct or not or the year is in the same format or not some record is like a Buddhist era some is Christian era นะคะ the way to check that we need to subtract the year from the date based on this command okay and then enter after you enter you will get the variable year dx and then you can tabulate year dx and then enter okay and then you look like for 1990 just only 4 record most of the patient died in 1994 okay this is clear for date of diagnosis and next I would like you to change end date into date of into date format I let you do change end date string นะคะ to date format you can do and walk around We need to generate that for English. It's at the same period because the period is there at 6 o'clock. Right now it's generate. I would like to like a refine you how to change the string to date format. That's the problem that when you input or record data in Excel file. When you export to Stata, the problem is like the format change to string is not date. Have you got this? After you finish to format end date, you need to check like which one that they cannot change. You cannot change or not. There are some missing. ค่ะ Like a year that there are like a year before 2000 นะคะ we need to specify if you don't specify inequality between the problem I think you are supposed to like the story about 2000 ofพี่ของที่เขาเป็นthat's like India 2000 So why the computer don't understand before 2000 and after 2000, then we need to like clarify before year 2000 and after 2000. But this is like the very old data set that date of that existing for the public. But in case after 2000, the quality is more. This isเป็นแบบคอมพิวเตอร์มันจะมีปัญหาตอนนี้เนาะไวรูเดียใช่ใช่มันคอมพิวเตอร์มันจะไม่รู้ถ้ามันเป็นปีก่อนเนาะ
ถ้าสมมติว่าทำไปแล้วมันดีแล้วเราแค่ดีกว่าจะเป็นได้เจอกัน
ใช่
เราเป็นคนทำดี
แต่เผอิญเมื่อก่อนเนี่ยเราคือมันเป็นต่อมันก่อนแล้วก่อนก็มีการ in case that you have like this between 2000 before 2000 and after 2000, that's why we need to specify. However, you need to check and then make sure that it can completely be regulated. And in this case, it's because all year is before 2000. If you use the function D and Y, it can like the same the result. But if the data is between 2000 before and after 2000, sometimes we need to connect to them. Probably like the last version of this data for the first one that we need to okay, yes, also because before 2000 the date format become the negative value and after 2000 it's like a positive value. And I think probably this is like the new version probably and like also that over before. Or probably you can change the slide. Delete 19 นะคะ change like a delete 19 and then probably the version transfer is over. This is like the way to manage the data, the date of spring, the date of. Next, after we manage the date format, the next step is to declare the survival time. But at this time, we need to setนะคะ and then follow by end date or last date นะคะ and then comma origin is option and then specify time date diagnosis and then specify failure outcome equal 1 and then scale is meaning when you specify date end and original date นะคะ the unit of time that calculate is day And if you like to change it to month, scale in month, you need to use the command, add the option scale, and then 30.5 is for year, for month, and for year is 365.25. Scale will change to year. นะคะ okay, we can work it together นะคะ okay, ST set นะคะ follow by the end date or stop date that you will change the format already นะคะ and then comma specify the origin refer to original date which is this study is date diane and then specify failure. The failure, what is the variable patient status? Like a failure, and then in parentheses is the variable that show that record patient status นะคะ What variable that show patient status? The variable outcome, ไหม To present the patient status, the variable name is outcome นะคะ and for the outcome patient status as you can see on the slide that I checked first, one outcome, one equal date, two equal follow-up. So the outcome that we are interested, specify failure outcome equal 1. And if you enter, I would like you to enter. And it shows that 235 total observation and 4 observation end or before enter นะคะ It means that 4 record that the time is negative or 0 and it remains only 80 patients have failure or death and as you can see the last observation exit T equal 1,273 the unit is day นะคะ Could you please select the previous command and then you add the option scale and then in parentheses if month divided by 0.5 for month and then enter. As you can see, the last observation is 41. It means like a 41 month, right? If you like to change to year, okay, you change the scale to 365.25 to change it into year, nah? The unit is year, okay, this one. Okay, it's 3.4 year. Maximum is 3.4 year. And as you can see, the option at the beginning, they will say outcome equal 1, original date, and end date,นะคะ, for interval, time interval, original, and then end. Failure, and then time origin. Time origin is divided by 365 is for year. After you declare the data and you found that some observation that end or before enter, it means that cannot apply for survival analysis. For record will remove. You can tabulate underscore st. Can you remember that goes at 1 and 0? 1 is for the record that can calculate the time, and 0 is mean cannot calculate the time because probably end date is occur before original date. So we need to check what problem that occur for observation that cannot calculate the time. You can risk the subject ID because you like to know which subject ID, and then date diet, and then end date, end date, end diet, okay, and then what else? Patient status, variable outcome. If underscore st อะค่ะ equal นะคะ after if equal what คะ zero or one zero right and then enter what the problem คะ yes the diagnosis ended is exactly the same right so we need to recheck the data what something wrong in this whole record probably you like a record something wrong or even though if diagnosis and end date is exactly the same day it means that this subject for case cannot include in our analysis right because it's like the event occur at the beginning right so we can ignore okay because this is like a date at diagnosis or some case they think that for the severe disease after we diagnose the patient and diagnose in the morning and date in the evening so we can like plus date of diagnosis plus one it means like the time for like a time to event is 1 day it depends on your condition some disease can be occur diagnose in the morning and then the patient die in the evening but in some case I think it's not possible you need to revise the data or like remove this whole record okay I assume that this whole record is not included in our analysis because they die in the same day of diagnosis the next step how we estimate the median time and death rate what command the rest is exactly the same you can use the command อะไรคะ stsum right and then enter right now the unit is year right the number of subject is remain 231 because full record is removed from the analysis we not necessary to like set the condition because it's automatically based on underscore st full record will remove if we still like a disease we should exclude นะคะ and what the median time 1.45 year ใช่ไหมคะ about 1.45 year it means like 50% of the patient survive longer 1.45 year นะคะ and how about death rate 60 patient per 100 patient per year นะคะ in case that you like to estimate 95% confidence interval you can use the command stci and st rate and in this case นะคะ if we would like to estimate the survival probability you can STS and then risk right and then enter you will get like all time ค่ะ because they sort the time from smallest to largest and then at the beginning as you can see at least the number of subject is total subject and at this time 5 patients die fail and 1 patient censor and they estimate the survival function and then 95% confidence interval and after that for 005 year the subject remain 225 At this time, 6 patients die and 1 is censored, lost to follow-up or still like a lost to follow-up or withdraw from the study นะคะ and as you can see if I ask you like how about the probability survival probability at 1 year you need to look at the time and try to find about 1 year this one is about 60%, right? The survival at 1 year, like a probability to survive after 1 year is about 60%. And in case that you have like a many, like 1,000 or 2,000 record, it is very hard to find, right? 1 year, 5 years, 6 years. So you can specify, could you please go back to STS risk and then comma ค่ะ at and then you like to show only 6 months it means 0.5 year right and then 1 year 2 year and 3 year and then when we report into the table not necessary to report like all point of time normally have you heard like you can when you read the article they ask about 5-year probability right or 3-year or 1-year probability and then enter ค่ะ and this is easy for you you can use this table to report 1-year survival or first is like a 6-year survival it means like a 70 probability of survive after 6 months is about 71%. And the probability of survive after 1 year is 61. And the probability of survive after 2 years is 41. Right? The probability of survive will decrease, right, after the time pass by. Okay. And if you would like to plot the survival function, you can STS and then graph and then enter. No, this is the survival graph because the number of subject is around 200. That's why you say like it's like a very like a small for change the survival function. No? And for this survival function, as you can see that the graph still like is not close to 0. It means that the last patient still alive. But sometimes you can see that this survival function is like a control for this one. Okay, for this one, for this graph, as you can see that at the end, the survival function becomes 0. In this case, it means that the last patient died. The survival function like a drop to the 0. But if the last patient still alive, it means that the graph will show you as this one. Okay, it means that the last patient still alive. But if the last patient die, the graph will like go to 0. Okay. Okay. Okay, this one, no? And in my slide, I manage 4 observations. If this is the severe disease, it means that like a diagnosis in the morning and death in the evening. You can do by this one, revise the date by plus 1 day. And then the way that you apply data, you need to replace the end date equal end date plus 1. If underscore st equals 0, it means that the observation that cannot calculate the time. And I just plus 1 day for 4 record. And after that, we redeclare several time again. If you do not redeclare, it's still the same, like it's still like the same result by remove 4 patients from the analysis. Every time that you revise, first we declare several times, right? And detect some record that has problem. And after you revise, you need to redeclare again. At the end, you will get 0 exclude. No? And then you will go to step by step, ST sum, STS risk to estimate median time, incident rate, and probability of survive for each time. นะคะ clear นะคะ I will move to the next scenario นะคะ single record per subject and record date start date stop but however the year that they record is mid year between Buddhist and Christian era. We need to manage the data first before we declare survival data ค่ะ Okay, let's look at this example นะคะ This example focus on the patient with renal transplantation. The outcome of interest is graft failure. Sensor is non-graft failure and loss to follow-up. And in this case, start date is date of transplantation. End date, if the patient have event, the end date is date graft failure. If the patient do not have event during follow-up, the end date equal date last follow-up. Okay. This one. The data format will look like this one. As you can see, the code 1, this is the variable status is referred to patient status. 1 is referred to graft failure. It means that if the patient has graft failure, they will have the first column is date operation. As you can see, this it's not mixed now. This is date operation, and the second one is date last follow-up for each patient. And however, if some patient have graft failure, so they will record the graft date of graft failure, which is different from date last follow-up. นะคะ Date last follow-up is like a follow-up until at the end of the study. But however, graft failure occur during the period of follow-up. So if graft failure occur, like a researcher will record date of graft failure, and also they record date of last follow-up too. Okay, we have 2 date graft failure and date last follow-up. Okay, this is graph function. 0 is referred to graph function นะคะ this is the data นะคะ example number 5 that I would like you to open for the case scenario 5. Okay, after you open the data, I would like to show you that as you can see, the operation mix between Christian era and Buddhist era. นะคะ And the date graft failure, if the patient have graft failure, date graft failure not equal date last follow-up. The date last follow-up is longer, right? Because graft failure occur during the follow-up period. Okay, this is 2 points that I try to emphasize นะคะ โอเค example number 5. First date of date of transplant is like a date operation นะคะ First you need to list the subject ID and date of date operation. This is the starting date นะคะ and then we have date last follow up. The variable is date last and then have variable date graft failure. This is date of graft failure. And the variable patient status is like a graft fail. And then you in 1/5. Okay. And next, we would like to look at the format of date. This is date format or not นะคะ You describe change list to the command describe and then delete in 1/5 นะคะ No, we just look at the format first. Okay, enter. And as you can see, date operation, date last, date graft failure is date format already, right? No need to change at all because it's date format. The next step, we would like to check the year of operation date ของ graft failure and date follow up. It should be in the same format. Okay. So can you remember you generate year of equal function year and then for which variable คะ date OB เนาะ because we would like to subtract year from date of operation to look at only year of operation that is the same format or the same era or not นะคะ and then enter and after that you tabulate year of what happened คะ There are mix between Christian era and Buddhist era, right? So before we declare the survival, we need to collect or change into the same era first. นะคะ okay, this one. This I prepare for you นะคะ How to convert Buddhist era to Christian era นะคะ After you generate like a substring year operation from date operation นะคะ The second you need to replace year operation equal year operation minus 543 with condition if in length year operation greater than 2,500, right? Because we know that if more than 2,500 is Buddhist era, right? Right now, we would like to change from Buddhist era to Christian era. Okay. And after that, after we replace or collect the year, the next step we need to combine day, month, year into the new variable with the same era นะคะ So the third command I subtract day from date operation and then I subtract month operation from date operation and at the end we combine them all together with the function mdy. So we start with month of, comma, day of, comma, year of. And after that, we format date operation and then %d. You will get the result on the right-hand side. Change from Buddhist era to Christian era. to understand. Okay, I'm going to check the graft failure and last follow-up. If it mix between Christian or Buddhist, Buddhist era, you need to change, convert into the same era. Last follow-up as we deal with graft failure. Check for three variable of date, no, to make sure that the date is correct in the same era, same year, in the same format. Year of some the same. If the year of graft failure is exactly the same, no need to change. Okay, and then move to date of last follow-up. If date of graft failure is the year is the same format, okay, just ignore and then move to the next variable, date of last follow-up.ต้องบอกเป็นปัญหาคือเราฟังไม่ถึงเวลาเรียนถึงแต่ความจริงของทุกสิ่งทุกสิ่ง Okay. Yeah, no. If you found that if you check year of last follow-up and year of the graft failure, if the year is the same era, it means that no need to go further, no? Just like a check and then stop. No need to generate the new variable. Okay. Can I move to the next step? No. after you, this is very important to check. If you haven't entered the data by yourself, let other body enter the data for you. Probably that we need to clear that it should be in the same format. So the next step, we need to generate the end date because this data set have like a two variable, date outcome and date last follow-up, right? Because this is not date. If the outcome is date last follow-up and date should be like the same, right? But in this case, graft failure is occur during the follow-up time, right? So it means like the date of graft failure and date of last follow-up is different, but we need to calculate time to event. It means that if the patient have graft failure, it should be time to graft failure. Start from date of operation and until graft failure. But in case that the patients haven't graft failure, it's still like a free of event. So the date or the end date, it should be date last follow-up, right? Because end date depend on the patient status. Okay. And right now we will generate the new end date. I generate date end, or you can set other name that you want. I generate date end equal date graft failure if the variable the patient status graft base GF base equal 1. For the patient who have graft failure, the end date should be date graft failure, right? And replace date end equal date last follow-up if graft failure equal 0. And after that, after you generate date, you need to format the date that you generate. And as you can see that I highlight, this is the graft failure record number 3. Subject number 3. Date graft failure is 5 July 2000. The date last follow-up is 19 October. Therefore, the end date is date of graft failure, right? And for the patient who did not have graft failure, the end date and date last follow-up is the same. Okay. For the patient who have event, you need to replace date graft failure with condition graft failure equal 1. And end date equal date last follow-up if graft failure equals 0, and then format. Okay. I will let you do that. The next step is declare the survival data. Can then date end equal date graft failure, right? If the variable DFA equal 1. And then replace the n equal date last follow-up if DF base equals 0. And after that, format JM percentage. Yeah, and we got this variable. นะคะ finish all to finish okay move to the next step the next step is declare survival time นะคะ so we need to อะไรคะ st set follow up by date n right and then specify original time which is date operation but it should be date operation that you change to the same format already and after that failure graph weight equal 1 and then scale we specify as a year because this is long-term follow-up is about 10-year follow-up you need to declare have you finished to declare st set นะคะ and then date n that you generate already right date n and then comma specify origin date by the date operation and then specify failure is df weight O1 and then specify scale as year from st set okay and then enter okay and what the result 153 observation in or before enter that is have the problem now has the error that we need to recheck have you got the same I think probably I have Have you got zero exclusion or okay, that's very good. That's something wrong. Okay, if I found this is the error, I need to check what happened.นะคะ, that I show you subject and then date operation, and then graph failure, and then date n. If st equals 0 Okay, and I'm surprised that หมอคะเมื่อกี้I'm not sure that have you checked year of last follow up already ใช่ไหมคะ check already เลยนะคะ Okay, I know that. I know why I make a mistake. And as I show you that in case that I declare and I found that 153 has like a error ค่ะ end or before enter. So the next step that I need to check why the time cannot calculate. And as I observe that the variable date operation for me, I haven't collect it. And as you can see, date operation is Buddhist era, and the end date is Christian era. When this is like a minus time, right? Because date origin is like greater than date last follow up. This is the mistake that we need to check in case that it show like the record, the error record ค่ะ we need to check with the option underscore st equal 0 and I found that this is my problem นะคะ so I collect probably I haven't okay this one that I haven't replaced year of year of minus if year of and then after I revise or collect the data นะคะ after I collected operation so I need to redeclare again นะคะ if I haven't redeclare the problem is still there okay so after I revise date and then I redeclare again and then enter and zero exclusion okay and the next step is exactly the same if you would like to look at the median time this we call median time to graph failure right? And the graph failure rate how you do ST sum right in this case can you estimate the median time cannot right I will show you the reason could you please tabulate GF rate นะคะ and then how many percent of patient have graph failure only 11 right it means that in this case we cannot estimate the median time because the meaning of the median time is like 50% of patient have event right but this is not like the event occur only 11% so that's why we cannot estimate the median time okay you can do STS and then graph I'd like to show you STS graph and then enter and as you can see at 50 percentile or at 50% we cannot find จุดตัด cut like the cut between like a cross line อะค่ะ that's why we cannot estimate the median time in case that small amount of the case less than 50% that's why we cannot estimate the median time นะคะ and in this case the outcome is graph failure if you plot survival function this is called probability of free of graph failure นะคะ and it is better if you like to explain the probability of graph failure for each year you can STS graph and then comma specify fail to show the failure function is better because we would like to explain the probability of graft failure than the probability of free graft failure. Okay. And this is the probability of graft failure for each time period, for each time point. Okay. So when we report the result, we would like to report the result probability of graft failure at 1 year, 3 year, 5 year, and 10 year. Now can you do STS risk นะคะ and then comma fail because we need the probability of graft failure, not free of graft failure, right? And then add. This is unit is here already, right? We need to look at 1 year probability, 3 year, 5 year, and then 10 year. And then enter. And then you can report the probability of graft failure after 1 year is about 2%. And if 3 year, the probability of graft failure after 3 year is about 6%, right? And then for 5 year, if the patient after perform kidney transplant, and the patient asks how long that I can survive, or how long that the graft failure not occur, or graft not reject, graft not reject. So the doctor said if you follow up right now and then 5 years, it means that the graft probability of graft failure after 5 years is about 9%. Okay. And for 10 years, it's like higher, right? After kidney transplantation, and you can survive without graft rejection. Okay. If longer than 10 years, the probability of graft failure after 10 years is about 24%. But just in the first year or third year, just like small probability of graft failure after 3 years, right? And for 10 years, it's like a higher probability to like a graft failure. As you see on the STS graph, this one. The probability of graft failure is like a higher after the time, like a past. That this one, I show incident of graft failure, and then you cannot estimate the median time to graft failure. And this is I look at 1 year, 5 year. This one that I explained to you in my slide. And then this is construct Kaplan-Meier curve for failure function. Okay, that all for overall survival, like overall to estimate like the descriptive information for survival analysis is like a median time, incident rate, and probability of survive or probability of having disease. This is like a overall descriptive information. Okay. Does anybody have question about this point? For the command, you need to remind, based on my slide that I try to put it in step by step that you can like review later after this class. Okay. Before we go to the next topic about comparison of survival curve, or like you have factor that exposed and non-exposed, and look at how different of survival time between different group of exposure นะคะ I will give you like a 5-minute break okay and you come back it's not much I think just only 1 hour that we can finish now
ฉันเจอแฟนชื่อที่หนักคือจะทำก็ผมไม่ได้ลองได้จะสิ่งมาที่จะ
เหนื่อยไปซื้อชานมกินดีกว่าเล่าไป
เกี่ยวกับไม่รู้แต่ทีนี้ก็ใช่เอาแค่หลังตรงนี้พวกเราที่สอบยังไม่ต้องเอาต้นน้ำเลยชีแต่ว่าเอาข้อใจก็คือดูดิคือเฉยใช่ไหมคือเฉยใช่ไหมใหญ่เลยครับคนเมื่อได้อย่างเราเรื่องมาดูว่าเจจะไปอยู่เวทต่อเพราะแบบเจจะไปอยู่เวทมันไม่เก่งเจนคิดเลยสองวันจะเจดีเวทจะข้ามเวทที่จะแต่กินหมอว่าที่หนูสนใจเพราะว่าไม่ได้ยังตีสายปีแต่ว่ามันไม่สบายคือเราคนที่ไม่เข้าใจเราว่าคือการเอาชุดทำมาใส่คือชอบตัวเราเนี่ยใช่นะเพราะว่าเราซื้อไปเยอะซื้อไปแพงเราไม่ได้เรียนแต่ว่าไม่กล้าใส่เราจะไปร้านบ้านก็เลยมันไม่น่าจะใจดีก็เลยเต็มที่ไปเลยเขาไม่อยู่ตอนสุดท้ายไม่ได้ศึกษาคนเปลี่ยนไว้ถ้าส่งอยู่ตรงประมาณถ้าพูดถึงต้องดีใช่ค่ะให้ตรงนี้ที่ฉันเรียนจบในตอนนั้นเสร็จไม่เห็นจะคือต้องตายจะต้องอยู่ได้ยังบุญเลยก็ยังอยู่ตรงบ้านกินน้ำสมุนแต่ถ้าเข้าไปหมดนะอ๋อเดี๋ยวนะก็ไม่ได้คือโดยคือต้นน้ำเป็นอะไรน้องแบบที่นอนกองอยู่วิชิมากเราไปเราเปลี่ยนก็จะคิดเป็นตอนแรกของคนบอกไปเลยผู้ที่ขวาทุกคนให้ติดลมตัวลงกำลังจะให้ระหว่างจะไม่ยอมเป็นตรงนั้นเราเป็นตำนานเราก็เป็นชอบเอาไปที่ความรู้ของมันต้องเป็นความเป็นของแสดงว่าเป็นเหมือนกันเขาเป็นสารเก่งมากที่มันเนี่ยเป็นบนระดับสองของข้ามข้ามก็เขียนกับคนพ่อเรียนว่าจะทำย้อนมาสองจังหวัดที่เส้นทองจากเป็นการที่ใช้เราจะต้องเป็นคนไทยก็เพราะว่าเราเป็นคำว่าแต่ชีวิตก็เห็นว่าเขาดูแค่ไม่ต้องทำไปที่นั้นก็บอกว่าไม่ใช่ของถ้าเป็นว่าเราคงจะไปส่งได้ทางเอาใช่เราสร้างเราฝึกทำผิด
เราไม่คิดแบบนี้เราใช้ที่เราไม่อ่านตัวของตัวเองเราไม่ได้เรียนช้าเราไม่ได้เรียนช้าแต่ว่าเป็นช้าผมว่าเขาเลยบ้านเราคือบ้านเราได้สองคนแล้วก็มีแบบว่าจะใช้เราเดียวเลยว่าจะลองก็ถามแล้วว่าเขาเปลี่ยนมาให้หน้าตรงนี้เราไม่ได้เรียนไปเรื่อยๆฝึกเรียนรู้ว่าจะเป็นถ้าเป็นหนักต้องเรียนเราที่ชอบอ่านของเราไม่ได้
Okay, continue from the next. That is not more than 1 hour. I try to finish because this today is very long for you now. Okay. After right now you understand when you apply the several analysis now based on Kaplan-Meier can estimate median time, incident rate, and survival probability of having event at each time point. The next step is like the same as the previous, that we would like to identify the predictor or prognostic factor that associated with the time to event outcome. Okay, every time that we talk about hypothesis testing, right now we will skip to we will jump to like a hypothesis testing. The hypothesis testing, in this case for survival function, we use the log length test to compare the survival function or median survival time among different groups. For the null hypothesis, every time that we talk about hypothesis testing, you need to know that what is null hypothesis of that test. The null hypothesis for log length test is mean that survival function for each group 1 to k is the number of group comparison. Like the survival function for each group are equal, or the hazard function or the median time for each group are identical or are the same. This is the null hypothesis for log length test. This is the concept of log length test. They divided into that is D1 and this is D1 and D2 is like the different group. We have only 2 groups. For example, group 1 and group 2. They divided into like 2 groups and then compare the probability of survival or probability of death between 2 groups. So we divided into 2 groups, and after that we need to calculate the expected frequency based on this equation. The log length statistic is based on the concept of chi-square distribution that compare between observed and expected frequency, the same as that we learned in estimate OOE ratio. But the equation for estimate the expected frequency is different. Okay, this is the concept to calculate the expected frequency for each cell. And after that, we will this is the chi-square test for log length test. Log length test is distributed at chi-square with k minus 1. K is number of group minus 1. Okay, and then this is the log length test. This is group 1 and this is group 2, and then we estimate the chi-square test, and after that we convert to p-value. We will work on data. The same data set in example 5 about renal transplantation, and the question is they would like to compare between living related kidney transplant and cadaveric kidney transplant? How about probability of graft failure or the graft failure function are different or not? Okay, so after the last time we used the command st-sum, right? This is overall. You just add by, comma by, and then follow by the categorical variable. You can do log length test only categorical factor นะคะ For continuous factor we cannot perform log length test. We need to go to the congregation model, and this is we focus only categorical predictor ค่ะ So you use the command st-sum นะคะ and comma by and specify the predictor in the parentheses, and then you will get the result. Separate between the patient with CDKT and LRKT, no? And then incident rate, okay? The number of subject, นะคะ This is incident rate for CDKT and LRKT. No need to declare the survival time นะคะ Just declare in the first time, and after that you can type st-sum and then by. Okay, I'm going to show the variable this first. Type donor. Could you please tap type of donor first? Okay, like a two group CDKT and LRKT, and then you st-sum and then by นะคะ the variable type of donor, and then enter. Okay, and then you will get the incident rate before two group นะคะ The number of subject is the number of subject for each category. Okay, and then you get incident between two group. And next we would like, this is just only show descriptive information for each group นะคะ And next we would like to apply log length test. The command is sts and then test, and then follow by the predictor variable. And then enter นะคะ It will show like the 22 is the number of event or graft failure in CDKT, and 35 is the number of graft failure in LRKT. If you like, can you remember like the number of event 22 for CDKT divided by what? You will get incident rate dividing by this number, right? Time at least, can you remember? This one, time at least, number of event divided by time at least. Okay, you will get incident rate for CDKT, and the same for LRKT. Okay, and this is the result of log length test. The chi-square equals 0.38, and convert to p-value equals 0.5. What is your conclusion? Significant or non-significant? Non-significant is mean that the incident rate ใช่ไหมคะ graft failure rate between CKD and LRKT are not different, right? No. It means that the type of donor is not associated with the graft rejection. Okay. Next, about estimate survival probability นะคะ or you can create graph. Okay, I'm going to show you STS graph, right? And then you comma by type donor. Okay, and then we would like to look at the failure graph, right? Because this is the graph failure. Okay, we type fail. Okay, and then enter ค่ะ This is like a two line. If the two line of failure function is like a overlap อะค่ะ it will non-significant. But if the line graph like the failure function are different and the line are not overlap, it will show like a significant. It means that that factor associated with the outcome, with the graph failure. And this I have like an incomplete result. And then this is the log rank test นะคะ and then this one incidence rate between CDKT and LRKT are not different. And then this is the Kaplan-Meier curve นะคะ compare between CDKT and LRKT. This can compare more than two. It depends on the number of group do you have. Okay, I would like. Okay, could you please tabulate blood group ค่ะ Okay, we have 4 group, right? And as you can see, 9 is missing value, right? So before we start to analysis, to perform analysis, we need to remove the missing code. The way to remove, you need to use the command mvd code. Don't worry about the command for data management นะคะ just like try to learn mvd code and then follow by the variable blood group นะคะ comma mv equal 9. And then enter. And then you tabulate blood group again. Okay, the number of subjects is reduced. It remain only 470. Okay, the missing value, missing code we are not consider in the analysis นะคะ so we need to remove before we fit the model. Next, I would like you to look at the descriptive information among the different blood group. What the command STS sum, right? And then comma อะไรคะ by blood group นะคะ and then enter. Okay, and as you can see, this is the incidence rate for each group of blood. And then if you like to look at log rank test, you can use the command STS test นะคะ and then follow by the variable blood group and then enter. Okay, this is the result of log rank test. How about this factor? This is the predictor for graft rejection or not? No, because it's non-significant, right? And when we look at the incidence rate or graft failure rate for each group of like for each blood group is like not different, right? 28, 27, 25, 23 or 24, no, are not much different. Just only nearly for the graft rejection rate for each blood group นะคะ And in case that you would like to look at the probability of graft failure for 1 year, 3 year, 5 year, and 10 year ค่ะ you can use this command. This one, can you remember? This is for overall, right? If you would like to separate by type of donor, you just add by type donor. No? If not by, it's like a overall. Okay. And then the result show like a 1 year graft failure like a probability of graft failure 1 year in CDKT is about 4%, no? And for LRKT is about 1%. No, if you would like to report between CDKT and LRKT, or probably you can use the graph, the result is exactly the same. Okay, that you can combine, you can compare by Kaplan-Meier curve between 2 group, 3 group or more. Okay, or you can raise the probability of having event for each time point between different group, okay, by add the option by. Okay. For compare, you need to add the option by and then the categorical variable in the parentheses. No? Okay, that all for the log length test to compare the cerebral function between like among different group. Okay, next is the last for this condition. At the end, we need to estimate the hazard ratio based on Cox proportional hazard model. Because the outcome is time to event. This is like a semi-parametric method, Cox regression model. Okay, the model is semi-parametric method. As you can see for the Kaplan-Meier curve, you need to like explore just only one factor. But for the Cox proportional hazard model, that we can consider more than one factor or one predictor. For log length test, just only one predictor, cannot add more than one, cannot consider more than one. Just as like just only one by one factor with the time to event. But in case that you would like to explore the association between factor that related to time to event and adjust with confounding factor. No, you need to apply Cox proportional hazard model that can add several variables simultaneously to look at the factor that associated with time to event. No? And another benefit is can use this model, Cox proportional hazard model, to predict list of events or risk of death using patient characteristic included in the model. Okay. It's the same like logistic regression that you estimate the probability of having event or risk of having. But the outcome in here is like a time. This is the hazard function. It looks like the same as linear function, right? We have intercept. We have coefficient for each variable, but this is in terms of exponential because this is like the hazard function. Okay, this is cumulative hazard function. This equation is more complicated than logistic regression because they calculate the hazard function for each time point. Not only one equation, but equation for each time point. Okay, so after we need to estimate the hazard function for exposure and non-exposure, and then estimate like the ratio for exposed and non-exposed. At the end, you will get the hazard ratio. The way to interpret the result is like the same as odds ratio or risk ratio, but change the name to hazard ratio because we focus on time to event, not event. Okay, review on data. This command stcox can apply after you declare survival time นะคะ this command can apply after you declare survival time okay so this one okay right now you declare survival time already right and next we use the command stcock and after that follow up with the predictor no need to put the outcome variable นะคะ no just only stcock and then if I would like to consider CDKT and LRKT stcock and then I dot right because this categorical variable type donor okay stcock type of donor and then enter now it will show you like the Hazard ratio the Hazard ratio here equals 0.8 no the I compare LRKT with CDKT okay the Hazard ratio is less than 1 it means that the type of donor LRKT is lower or higher risk of graft rejection lower because the Hazard ratio less than 1 นะคะ the patient with LRKT have how many percent 15% right lower risk of graft failure than patient with CDKT however but non-significant the p-value is greater than 0.05 and 95% confidence interval is like a cover 1 นะคะ the Hazard ratio equal 1 is mean no difference right and the 95% confidence interval include Hazard ratio equal 1 นะคะ so it will consistency with the p-value this is non-significant LRKT is like a lower riskนะคะ about 15% compared to CDKT lower risk of graft rejection but however it's not significant and this is another variable that we consider นะคะ age of recipient sex of recipient and underlying disease นะคะ many factors that we consider okay in case that we our study factor is type of donor but we know that there are many factors that associated with the graft rejection นะคะ so we can adjust with the confounding factor นะคะ this is however the way to adjust is you need to perform univariate first นะคะ to do estimate hazard ratio for each factor one by one and at the end we can select only the significant variable and put into the model simultaneously at the same time and then we call multiple correlation model for this example I would like to look at the effect of LRKT นะคะ to time to graft rejection and as you can see that the previous univariate we get 0.84 is mean lower risk right and non-significant and after we adjust with confounding factor in this case the confounding factor is anti-HCV positive delay graft function and the drug is like a CSA and at the end we will get the hazard ratio of type of donor after adjust by the significant variable so the hazard ratio become 1.88 it means that the LRKT has higher risk right 88% more than CDKT เนอะ after adjust confounding factor นะคะ เนาะ so st cop if you would like to look at another variable st cop I dot I would like to look at tab HBS first. Okay, positive and negative, right? The negative is 2, positive is 1. You can st cop I dot SBS. Okay. If we compare the negative HBS is like a potential to higher risk ใช่ไหมคะ of gap rejection compared to SBS positive เนาะ and non-significant นะคะ if you consider more than one factor for example I put type of donor and then adjust by sex and adjust by SBS นะคะ this we call multivariate because we put many variable or many factor at the same time นะคะ and then enter so you will get like the hazard ratio for each variable นะคะ this is we call like a multivariate model and this is just only example but the step is exactly the same start with univariate analysis and then select only significant variable and put into the multivariate analysis, right? And at the end, you will get the final model that consists of small number of variables that can predict the risk of death based on the proportional hazard model. This one. This is like the flow or the step to explore like the factor that associated with the time to event. And at the end, there are like only one or two assumptions that we need to check. The first assumption is independent between time to event and sensor. It means that the patient who have event and did not have event, the distribution of time to event should be like independent. And the important assumption is the hazard ratio is proportional or constant over time. It means that the hazard ratio for each point of time it should be constant or the same, like the effect of hazard ratio should be constant for each time point. However, we need this is like in case that the assumption is violated, it will make like overestimate and underestimate in case that the assumption is violated นะคะ just keep and the way to assess independent assumption we will look at the plot. This is like a very complicated for you I think this is like too complicated but I just show you that we have plot the residual versus functional of time and then plot log of serval function with log of time that we call log plot. I just only show you this one. This is the plot between time and like the residual and how to interpret the result. A zero slope we will look at the slope. If slope is zero, show that this is no variation about proportional hazard assumption. But however, sometimes we just only visualize. It's very hard to make decision. So this is the good way to checking assumption about proportional hazard. We call like a log plot. If the plot is like a parallel together, it means that the assumption is not violated. But however, this is just only visualize and it's very hard to make decision. for the assumption of proportional hazard ratio, after you fit the final model, you can use the command estimate, pH test, and detail. You will get like the result for global test. If the result is non-significant, it means that the hazard ratio is constant over time. No, because the null hypothesis is all coefficients are constant over time, or the hazard ratio are constant over time. Okay, we will. For example, if I fit the final model as only 3 variables, for example, and then you can test proportional hazard ratio is constant over time or not by using EStat, pH test detail, EStat, pH test and then comma detail. EStat. After fit the hazard ratio, after fit the correlation model, you can use the command EStat pH test to use the global test to test about the assumption about hazard ratio to be constant over time, and then enter. And as you can see, the global test is significant or non-significant, non-significant, it means that this model, is like the hazard ratio constant over time. And if you like to plot the log plot, you can use this command, stph plot, stph plot, and then we would like to plot, compare between type of donor by type of donor, and then enter, and then you can look at, this should be parallel, to look at like the hazard function between the two groups. However, it is better to look at the test to confirm. This one for type of donor, it's like they look at the constant of hazard ratio for all variables that include in the model. So we have type of donor, as you can see, the p-value equals 0.2. For sex, the p-value equals 0.4, and the SBS, the p-value equals 0.9. And for overall, for the overall model, the hazard function is constant over time. It means that when you apply this model, the assumption is not violated. But if the assumption is violated, we need to change the model or use another variable, add another confounding factor, or use another equation. Okay, that I think just like the overall for the basic observable analysis. Just prepare the data for single record for single event. Estimate median time, incidence rate, probability of event, and then apply proportional hazard model to estimate the hazard ratio to look at the effect of each predictor to the outcome. And then take assumption. The important assumption is about the coefficient of all variables are constant over time, based on global test, and plot the log plot. I think that is enough for checking the assumption. And this is like the assignment that I would like you to use the data that we work on this morning advanced SCC project นะคะ but however I will give you more detail the main important like this morning อะค่ะ the data file for advanced SCC we have the start is like a date of receipt treatment and the outcome of interest is date and they have like a date of date and date of last follow-up so you need to declare survival like a declare survival time after that describe information descriptive information date rate median survival time and estimate probability of survive and construct the Kaplan-Meier that we learned this today นะคะ and after that apply the proportional hazard model to estimate the hazard ratio and then select only significant and put it into the Cox model at the same time นะคะ and writing and interpreting the findings and however I will prepare more information about the data file นะคะ about factor and about date of start and date stop just remind like a practice to use the command and interpret the result and I will give more information about the advanced SCC project data file okay, this is too much for today okay I will give you like a because next week we start on Thursday no Tuesday no class for Tuesday next week I will leave you like a try to make like a how can I say like a review no about the step of server analysis for today for next Tuesday free time no that you can study and work on and try to work on assignment and on Thursday Ajahn Natnali will teach you about compacting risk model and however I will attend the class and probably try to help all of you
Can you explain again the global test? I mean, if it greater than 0.05, I'm confusing this one with those we learned last time for the testing model because I remember for the last time for the testing model, like if the result is greater than 0.05, it means model is fit well. But for this one is quite different with that one, right?
It depends on the null hypothesis. The null hypothesis for goodness of this, the null hypothesis is like a model is fit well, right? It means that we would like the model to fit well. We would like to accept the null hypothesis. But for this test, the null hypothesis is or the model is the hazard ratio is constant over time. This is assumption. Yes. So it means that non-significant is acceptable because the null hypothesis is the hazard ratio is constant over time. If we reject the null hypothesis, it means that the assumption is violated, right? It depends on the null hypothesis for each test, or each test have a specific null hypothesis. So you need to know, for example, compared to mean, you need to know about the null hypothesis. The null hypothesis is the two mean are not different. And then you need to look at the p-value to reject or fail to reject the null hypothesis. Okay. This is the null hypothesis is this one that is a test of proportional hazard assumption. Okay, the null hypothesis is the function, the assumption, the hazard function is constant over time. That is the assumption that we would like to be, right? And if non-significant, it means that the assumption is not violated. But if significant, it means that we reject our hypothesis. It means that our assumption is violated. It's not good, right? The model that you construct is not appropriate because it's violated. The assumption about hazard ratio is constant over time. I'm not sure that upload like the module for you, no? Because we have the module for servo analysis that Ajahn Amarin prepare for us. Probably I will move to upload about the module อะค่ะ For me, just only the slide and the module that Ajahn Amarin try to write all of theory in that module. Probably I will move to upload the module. Does anybody have question? It's very long day. The brain is full. This is new for you, no? Just like a learning by doing. I think it's better like a learning by doing. Okay. Okay, finish for today นะคะ See you again on Thursday. For each assignment, I give you 2 weeks for each. Right now you have 3 assignments. This is enough for 2 weeks for each, but it's up to you if you think that it's like you need longer time to inform พี่มุก and then พี่มุก will tell like okay that allow you to have longer, but however please tell พี่มุกนะ if you need longer time because พี่มุก need to like set the system You can discuss together, but you need to work by yourself, not copy. Yeah, ค่ะ โอเคค่ะ Have a nice weekend. Yes, welcome. Hey, I hope you enjoy study this course. Try to have. Don't worry if you cannot understand at this time and try to rehearsal ทบทวน practice.
ที่เดิมแต่ไม่ใช่หนูเลยเพราะว่าเป็นการเป็นเป็นห้องห้องเรียนห้องห้องเรียนห้องตอนนี้เราเป็นห้องเรียนวันเข้าวันถ้าเราเป็นเรียนแต่ก็ต้องที่มันที่เราเคยแต่คำถามที่อยู่ในห้องคำถามที่ไม่ใช่ผมเนี่ยเป็นนี่เป็นอะไรที่เราต้องทำให้เราตามที่ทำงานอะไรเราแต่ว่าต้องมีห้าแล้วก็อะไรตามว่าเราไปเรียนเรียนเอาเรื่องเอาคือไม่บอกเอาเรื่องฉันไม่รู้เราไม่ติดปัญหาถ้าเราไม่ออกมันเป็นเฟรมเรียนเพราะว่าสุดท้ายแล้วหมดเพราะว่าตัวเราเดินที่ต้องแข่งขันเกี่ยวกับการชนะไปก็พูดกันการทำไปนะแต่เราทำได้ทุกครั้งเพราะเทียบกับที่เราทำในห้องเรียนกันได้ก็เราจะได้ไปไม่ถูกเอาเองใช่เนี่ยผมเสร็จแล้วดูไปในตอนของเองเราเดี๋ยวเราจะมาที่แรงอะไรนะมันเกิดเดินไปเริ่มเฉยยิ่งเรียนเข้าไปแล้วเดี๋ยวก็ลองไม่เหมือนเลยนะอันนี้แบบผมคิดว่าดีแบบนั้นอ๋อมันอยากด้วยใช้ส่งว่าคือเป็นแบบที่เธอตอนที่เด็กไม่ชอบดูที่มันเป็นโค้งการได้บอกว่าเป็นผู้ที่ได้มาที่ได้ด้วยมาสามารถความสุขในเซ็กซ์ได้ด้วยแล้วเราก็จะได้คนสาวแล้วที่เราคิดว่าถ้าเราบอกตัวแค่เราทำอะไรมันเดียวกันเราอยู่เป็นแต่การและที่สองคือตัวไปว่าเอามาใช้พอเสร็จแล้วไปเอาไปโดยเลข9คือนั่นหมายความว่าเราคือ2 3โอกาสที่จะได้เองก็สั่งขึ้นแล้วให้พ่อหรือพ่อให้เราไม่เยอะแล้วเราเราสิ่งที่เราแบบพ่อแต่เราแรงที่ดีขึ้นเองแต่เราอยากสื่อสารได้แต่ให้มันติดกันกันเราก็ต้องทำที่ว่าในแง่ของสเต็ปเด็กขายพวกในกลุ่มหนึ่งเป็นแบบว่าเซ็งแต่เราต้องทำอย่างนี้ เจเนอเรชั่นที่มาเป็นแบบร้อยแล้วก่อนเราเรียนว่าเซ็กนะเราได้มาสิบอันแล้วก็มาเก็บแต่อาทิตย์นั้นเซ็กอีกพอเลี้ยงคนเดียวใช้เก็บตั้งเซ็กว่าฉันจะได้อันนี้เป็นเซ็กในค่าตัวไหนอีกเซ็กนึงก็ได้ถ้ามีร้อยเซ็กก็จะได้จะได้ของเราแล้วเอาไปเลยอะไรอย่างเงี้ยแต่คอมทั้งหมดนะเป็นแบบที่เขาร่วมกันเป็นที่ของอันดับสุดท้ายอ่ะจากการนั่นคือผมก็ที่บอกว่าแต่หน้าที่เราล่อถ้าเราไม่ที่นู่นคือที่เยอะความจะดูว่าเราก็ต้องใช้ตัวเพิ่มการหัวอะไรแต่ถ้าเกิดว่าเราให้มันทำเป็นตัวในที่สุดใช่ไหมเราต้องเนี่ยเราก็อีกที่ก็คือคืออะไรเราความแล้วก็แบ่งในส่วนของแต่ที่เหลือของเป็นแบ่งแต่เราเที่ยวไม่ใช่คนเก่งปีที่หน่วยลงคือว่าการข้อมูลครึ่งปีคือที่ไหนคือที่ไหนคือตอนแรกเก็บข้อแม่พูดว่าแต่ว่าที่แบบหรือเรียนบ้านก็คุยกับข้าวในที่ที่สำคัญเพื่อนดีตั้งแต่ในวันที่ก็เป็นของเสร็จแล้วข้อมูลที่ดูก็เป็นสิ่งที่เจอแบบที่เก็บตั้งแต่ดูที่ที่ก็คือหมายถึงการบางอย่างเก็บโดยเสร็จโดยไม่ได้แล้วต้องมาหรือถ้าแบบเก็บตอนแรกบอกอันนี้มันจะเด็ดแล้วเราที่ดูถามว่าคำว่าสปินหมายถึงว่าเป็นข้อมูลใหญ่แล้วก็แบบเพราะว่าเอาหมายถึงว่ามันเป็นข้อมูลเราจะเก็บของสิ่งที่อยู่ก็ได้เราที่มาหาเนี่ยต่อเป็นการต่อเก็บต่อแต่ถ้าเป็นความเราทำว่าทำได้เก็บแต่เราทำก่อนแต่ระหว่างเนี้ยเราก็ไปเก็บแต่มันเป็นตัวแต่จริงๆการเก็บมันเป็นเรื่องว่าเราเก็บช่วงหนึ่งการประเมินและการที่เราเป็นการลงทุนก็บวกที่เกิดแต่เราไม่ยอมความเสี่ยงเป็นนี่ค่ะ